It's a pleasure to introduce you our second invited speaker, that is Enrique Alfonseca. And he's a research scientist. I don't know if it's a principal research scientist, but he's leading a group in NLP in Google Zurich. And he earned his PhD in Madrid long time ago. And I don't know, I don't see Felice here, but I believe he's younger as Felice. We had a discussion yesterday about our age. So I hope you will enjoy the talk, and I'm sure you will discover many things that we are using in our everyday life. He's one of the responsible for that. Thanks.
Thank you very much. Thank you for inviting me. It's a pleasure for me to be here. And I'm going to be talking to you in general about language technologies at Google and the industry. And I will start with this graph, which I could find about a year ago about jobs, but it shows you how the number of job postings in the area of language technologies, language processing, has been growing a lot in the past 2012, 2013. But I can say that in particular in Google, so the red line is academia, the blue line is industry, but in particular in Google, NLP really has exploded in the last 2 or 3 years. And this is something that you can see not just in my company, but many consolidated tech companies are investing in NLP, Microsoft, Apple, IBM, Facebook, companies that have an expertise in a certain side of it, like Nuance for speech, Lionbridge, Cistran for translation, Appen for corpus annotations. You have many startups being created and appearing, disappearing, being bought, whatever during the past few years. But then I think a change of paradigm is that where I live in Zurich, you also see many traditional companies now investing in these companies like Swiss Re, Zurich Insurance, that they have lots of unstructured data and they need to analyze this data for applications like risk analysis, trends predictions, for all of these things. And they're actually posting jobs and hiring people for doing language analysis for their big corporate they have. In particular for us in search, we are seeing more than 100 billion searches per month, and 16% of them are new every day. So this means that the number of queries that people come about, the creativity is their language is very productive, and we keep seeing many and many searches that we have never seen before, and we need to be able to answer these searches and to understand them. And another paradigm shift that has happened in the past few years is the transition from desktop to mobile. The global smartphone penetration now is 1.9 billion people in the world with smartphones, and this is expected to keep growing in the developing countries in the next couple of years very, very drastically. In the US, I hear different numbers between 60 and 70% of the population has a smartphone now. And what everyone is mentioning now is that more than half of the searches are coming from mobile devices, from phones and tablets compared to desktop. And this allows a very different interaction with the user, because with the phone it's much more natural to be speaking to the phone than it is to be speaking to a desktop computer and to listen back through text-to-speech. So with the phone, we also know that the user is moving from here to there. We know the location, we know the context. We have a lot more information that we can use to have a more natural interaction with them. And all of this has moved the industry towards the paradigm of search companies being personal assistants, having natural dialogues with the users, having knowledge, language understanding to understand what the user is saying, to understand the corpora that the user has, personal corpora, and access to public corpora as well, the context of the user, and to be able not just to answer reactively to user queries, but to be proactive in assisting and suggesting to the user. This is just one example of let's see. Of a possible dialogue, this is something that it was working already more than a year ago.
Okay, Google, what does lemongrass look like?
Check out these pictures of lemongrass.
Okay, Google, what is fish sauce?
Fish sauce is an amber-colored liquid extracted from the fermentation of fish with sea salt.
Okay, Google, show me directions to the nearest Thai takeaway.
Thai corner is 5 minutes from your location. Here are your directions.
So this is a kind of experience that you can expect to see growing and growing very fast in the next couple of years, to be able to have more and more complex dialogues with Google, and to have Google as a personal assistant, as you treat a human personal assistant, schedule meetings for me, give me information, let me explore deeper in a certain area of knowledge. All these things should be happening more and more through dialogue. And in particular for that, one area that has had a lot of investment. A couple of years ago, Google didn't do any question answering, any unstructured question answering like this. Now it can answer many questions, things like how to divide by 0, or what is the largest flower, more factoid questions where the user is looking for a certain entity, what's in a 7 and 7, recipe questions, how to bake an apple, directions, how to's, New York elevation, and it may be that the answer is not just free text, but it may be semi-structured data, tables, lists on the web. And even more complex questions with involving some kind of compositionality. Who plays saxophone just the way you are? And you need to have some understanding to be able to ask questions like this and to match text on the web and to find the right entity. Of course, we make many mistakes as well, but all of this is work in progress. But the takeaway message is that the search engines now are helping us to reach people in the moment that matters across all devices with smarter results that are relevant of the intent of the user and the context of the user. Like, you can go to Google now and say my photos of animals. And if you're logged in, Google knows who you are, knows that you may have a Google Photos account where you upload your personal photos. And then through all these photos are in my albums. They are not tagged in any way, so they don't have labels, but through image recognition also we can understand what are the objects in these images. We can understand that all these objects, penguins, kangaroos, all of these are actually animals, so all these photos would be good answers to these queries. I was mentioning assistant suggest, so telling the user, you have a plane, you are now in this location, you should leave in the next 15 minutes if you want to reach the airport on time, for example, and you're flying to this place, this is the weather in the place you're moving into. And something that's very important and was a paradigm shift is when Google acquired MetaWeb, who was the owner of Freebase, and then started building this knowledge graph around Freebase. Freebase was a database with, at the time it had like 20 million entities, but then all of this was reconciled with the databases that were internally at Google, product databases for products, for locations from geo, for books, and so on, for Google Plus public identity. So all of these things were merged together into a single knowledge base. We have this knowledge base with like 600 million entities and 18 billion facts about them. And this is something that has allowed us to ground all the language understanding on the knowledge base. So to identify mentions of entities in the web based on this, on and relations between them, explicit mentions of relations, events about them. Something that's quite important is to keep all of these up to date. So one application where my team was working a couple of years ago was understanding from the news when something has changed in the real world and we should update the knowledge base. So for example, if we see that from the news that someone has died, we want to identify the event that the person has died and the related information, the date, the location of the death, the cause of the death, and semi-automatically put all this information in a knowledge base in a way that it can directly surface to the user with as much freshness as possible. We now have query understanding. Part of my team was also involved in these things. It's very, very simple, so you will not be surprised by these things, but at least now you can have a voice search conversation with Google and ask, who is Petra Nemkova? And then a second question to say, who are her parents? And we understand that the second question is referring to an entity of the first question, and we can resolve the pronoun and handle the query in the right way. And the actions team also in Mountain View has been working hard to understand many possible ways in which people can ask actions to the phone and other devices, like sending emails, create appointments, opening applications, getting directions, and so on. Other areas of application where there's been recent progress, and a lot of it has come from deep learning, from deep neural networks. One of them is machine translation, and in machine translation, something that's been a bit of a revolution is using just recurrent neural networks for sequence-to-sequence translation, and this was a very big surprise when it happened. This was done by Oriol Vinyals and some other people from the deep learning team. They took the training corpus from machine translation and they just trained an LSTM, which is a certain kind of recurrent neural network that can store long-term memory selectively in the internal states, and just train the network to produce text-to-text translation. So there is no linguistic information fed to the network. The network just sees as input the sentence in the source language and is expected to produce with the highest probability with a beam search the sentence in the target language. And it's fed all the hundreds of millions of parallel sentences that we have. And just like that, it gives a result that is comparable in blue score with the state-of-the-art baseline system. So it didn't beat the state-of-the-art, but it beat some very common and complex baseline system, which is a combination of many systems with a lot of knobs that have to be adjusted and so on. And this is just a very simple system that without a lot of tweaking, it only has the typical parameters to train the network, the learning rate, and things like that. And then without a lot of, it's a very a very general model, and it worked quite well. And then as you can imagine, the way this is trained like this, it cannot really translate unknown words because it can only translate words that it has seen before, but with some improvements for handling specifically unknown words, they were able very quickly to improve this blue score up to 37.3 more points than before. And another similar application from the same people was for image captioning, and this links with what I was mentioning before, that we have lots of images that we want to index and we don't have labels for them or captions for them. And then there is this task, this open task with this data set from Microsoft MS Coco with 300,000 images and 5 captions per image, where people try to create automatically captions for the images. And so this is actually a solution that this team from Google came around with, but actually 4 different teams published a paper using exactly the same technology with only small differences from Waterloo, from Google, from Facebook, and from Baidu, I think. So all of them basically, this is the time that this technology is ripe, and then everyone is trying the same thing. And the idea is very simple again. Take a recurrent neural network, feed as input features extracted from the image from traditional image recognition approaches with convolutional neural networks. And from these features, the network is expected to predict the caption. So it's to predict in a similar way as the previous network from machine translation. Only the input, instead of being the source language, is just the feature from the image. And it can produce things like this. You give it this picture and it produces a text, a close-up of a child holding a stuffed animal. Or you feed this other text and it produces a person riding a motorcycle on a dirt road. And something that is actually quite nice is that you can train these LSTM networks with attention, which is a procedure that during the coding, when it's producing the caption, you have a special matrix that is also trained to tell the network which part of the image to focus on. And then you can, at inference time, while it is producing the caption, you can also see what the network is focusing, and you can see that when it's producing the word motorcycle, the network is focusing on the pixels around the motorcycle, and when it's producing the words dirt road, it's focusing on the background of the image. So it's quite amazing that all of this is happening. And then this is not the state of the art, but it's also interesting. You can again take the same network and just use it to produce a linearized representation of a parse tree. So you feed it, you take, you can use try training. So you take 2-3 existing parsers, you run them on the web, and whenever all parsers agree, you assume that's a good parse tree for the sentence, and in this way you can produce millions of training examples. You linearize the parse tree and you feed them to the network, and given the input sentence, you expect the network to produce this sequence of parentheses and constituent types and part-of-speech types. And just training it like this in an ensemble model where you train several networks and then you average the predictions, it can get 90% labeled accuracy for parsing, which is comparable to the state of the art. It's not the best system, but it's reasonably good. And I wanted to bring to attention also this recent work from the parsing team in New York, David Weiss, Slav Petrov, Michael Collins, that they train a directed neural network. It's an approach that is inspired by this one from Chen and Manning from last year. And then they took a very similar model. For every word, while you're parsing, you take a context around the word, you train a directed neural network to predict what's the next action to perform by the agenda-based parser, by the shift-reduced parser. And then they put a perceptron layer on at the end that is fully integrated with the neural network, that you can train the perceptron together with the neural network through backpropagation. And this is, as far as we know, both the most accurate and the fastest parser available in the community for English and for many other languages. And finally, something that I wanted to bring attention to is that, of course, Google is a global company. We live in a multilingual world. So something that's very, very important for Google is also internationalization. So NLP is used in many applications nowadays. This is just a selection of them, but given inbox email messages to automatically find tasks for the users to put in the task in the to-do list, automatically detect when an email is describing an upcoming flight or an upcoming meeting or a package delivery, all these kind of things. When you're writing a document, to have a research tab to assist you, to provide you with tables and graphs and additional information that might be helpful for what you're writing. Letting advertisers target users based on entities, not based on raw keywords. So to be able for an advertiser to say, I want to target any user looking for a flight from Europe to USA, and not have to worry about writing all the list of thousands of possible queries that the user might be interested on, but just explain this in a more knowledge-based approach and do the targeting. And of course, Google Translation is a core NLP technology as well. And internationalization, you can see it in all of these different applications. Now, in the second part of the talk, I would like to give an introduction of how a language technology team works at Google, a team like mine. We are part of Google Research, so we are considered to do research, but in Google, the boundaries between research and engineering are very fuzzy. So it's not like there is a research organization that is a completely different department. So we work very much on top of the products. We are pretty much applied research organization. So normally, when we start working on a topic, we should have an application in mind. This doesn't mean that this has to be very immediate application. It doesn't mean that we need to have launched something in 3 months or in 6 months. So for example, you have people at Google working on quantum computing. We expect that there will be very important applications for that in the future. We don't expect it to happen in the next few years. but this is an investment that we want to do because we think it will bring value to the company in the long term. And secondly, there are ways to measure progress, which is something very important. In our case, normally NLP is closer to products than quantum computing. So in our case, normally we do have products that come to us and say, I need from your expertise and I need you to invest on this area. And then we partner with the product team and we try to identify what are their needs and how can we solve them. And it's important for us also not to rely, to take into account our previous expertise, but not to rely too much on that. Not to say, I have a lot of expertise on this technology and this is my hammer and I'm going to use it, but really start from the product, see what are their needs, and be open to try a completely different approach than whatever we have been working on in the past. And then the evaluation is very much done on the product. So we may have a more generic technology like parsing, for which we have intrinsic evaluations, and those are important. But if we are using, for example, syntactic analysis for a product, while we work with this particular product, we rely a lot more on the extrinsic evaluations, on whatever the product considers to be the success metric. And something that's very important as well is that we never keep the test sets for very long. So we run mostly live experiments, where these experiments is where we use our technology directly for interacting with real users. So for example, we might be using language features for improving ranking, and then we put our approach into production, and then we see immediately we might divert 1% of the traffic to go through our approach. We can have another 1% to be the control experiment with the current production system, and then we can have all the live metrics from there. And then we have no test set. It's whatever the random 1% of the traffic the users are writing there, and whatever queries the users are writing in the 1% of the traffic that is used for control. If we do offline evaluations, we normally have rolling sets that we update very often. Sometimes even for every evaluation, we have a new random sampling of queries, or if it's not for web search, whatever it is. And otherwise, we may have a sample that we stick to for a little while, but we try to update it very often to avoid overfitting, of course. And then for every launch, for every improvement, there is some external independent voice that is judging that. There are some quantitative analysts in Google in every different product area, and they have to look at the outcome of the experiments to understand what we are doing and to issue their judgment about it, which is often negative as well. But it's better that someone who doesn't have any stake on the experiments can be completely objective and can have their voice, which is ultimately what is listened to. And then a third point is also to put the user first. And sometimes we have a research agenda. We say it would be cool to solve this through this method, and it would lead to very interesting problem. But sometimes we look into the problem and we see, oh, but it looks like we can try this simple heuristic and we solve 95% of the cases. And then we can use this straight away. We can launch it. We are already bringing this to the user, which is good. So then we do that, even if it means a delay in advancing the research. And then after it is in production, then there is the remaining 5%, and then we can do the interesting research afterwards. But if we can have some way, some easier way for having it out and impacting the users earlier, we try to do that as well. And then as a research team, from everything I said before, this is a bit redundant, but we also go all the way to production. So it's not that we have our own research data sets. We do our experiments, we have a prototype, it looks positive, and then we transfer the knowledge to an engineering team to put it in production. And we think that works sometimes, but we are making it harder for it to work if we go in this way. Because quite often, once you try to put something in production, there are many reasons why your original idea cannot be used straight away. It may be that you have latency requirements, that you have a budget of 5 milliseconds per query to do everything you need to do, or any other external reason why you need to change your approach. And as a research scientist who has developed some technique, we are the experts and we know what are the right trade-offs between latency and quality that we can take. If we just took our idea and gave it to an engineering team, they would have a much harder time finding the optimal solution for all these trade-offs. So we believe it is much better that the research organization is involved all the way up to putting things into production in the end. And finally, something that also happens very often is that everything constantly changes at Google. So right now, I had to do some code changes to some part of the search backend that I had not modified in the past 4 years. And when I went to see the code, I was surprised that absolutely everything was completely new. So the experience I had from modifying that from 4 years ago didn't help at all, because the infrastructure running in the data centers is evolving all the time, and also the code of the backends and the amount of data that we have to process and we need to have available at serving time is also growing all the time, which means that quite often very big things, like even the search backend, has to be rewritten from scratch. And then infrastructure we're relying upon has changed, and then if you want your things to continue working, you have also to rewrite them. So we have to be very adaptable to that, to respond very quickly to changing priorities as well. And it's very important not to get attached to problems or methods. If we see that the environment has changed, we have to adapt very quickly. And even if we have made a very strong investment in the past on a particular technique, a particular method, but we see that something better is now coming along, it's better as quickly as possible to stop working on the previous line and to switch to the new one and make further improvements from that. Okay, so and now I'd like to talk a little bit in the third part of the talk about some recent work that we did on sentence compression. And this is a work where we have been working for a while. We believe it's very important to be able to summarize and compress information. Also talking about the mobile devices and other devices like the watch or the glass, and in particular the speech interfaces. Sometimes we have answers to user questions, but they're very long to read. We can extract a certain passage from the text, from the web. It might be even a single sentence, but a long one, and it might take 20, 30 seconds to read, and it doesn't lend easily to a natural conversation with the users. So this is an area that we think is important to be investing on. And the problem of sentence compression is when you have a longer sentence, like this particular example from a news. Some 32-year-old biker recently rescued a badly injured kitten he found at a gas station while riding cross-country from Nevada to New Jersey. So you have a long sentence like this, and you want to produce a compression for it. You want to produce a shorter version of the sentence, like biker rescued a kitten while riding to New Jersey. So there are two ways in which sentence compression, extractive sentence compression, where you just select words for producing the compression. There are two main ways in which people have addressed this problem in the past. The first one is to label every word and to decide which words to retain and which words to drop. And to produce the golden compression I was mentioning before, we would need to label biker rescue the kitten while riding to New Jersey as 1. All the other words should be labeled as 0. And the second approach is to go for a tree pruning approach. You can take the parse tree of the sentence. This is a modified parse tree where there is another root edge from a fake root to all the heads of the different clauses to be able for the compression to be routed on any particular clause. And then the idea is that we can take a fragment of the text. Some systems expect it to be a fully connected fragment. Some systems can take separate fragments, and then taking a fragments like those, You select the relevant parts of the parse tree, and then you construct a compression like this. Now, the training data we have been using for a while is based on this idea that titles are normally compressions of first sentences in the news. In the news, normally the first sentence states what's happened, and it's a summary of the whole article, and then the title is a much shorter summary of that first sentence. So we can go to the news and we can take a first sentence of the news like this. We can take the parse tree, and then we look at the headline of the article, like British soldier killed in Afghanistan in this case. And we identified all the different nodes in the parse tree that are mentioned in the title. And then we take the minimum spanning tree that includes all these nodes, and we consider that to be a good compression of the sentence. In this case, a British soldier has been killed in a blast in Afghanistan. And in that way, going through the news in the past 6-7 years, we could produce 2 million sentence compressions. That's what we use as training set. The quality is relatively good, so we did analysis comparing these compressions with manual compressions, and they have similar numbers in terms of readability and informativeness. So these are comparable. There are a few mistakes sometimes, occasionally, but most of the times these have a quality comparable to human-made compressions. Now, the research question we wanted to ask, and this is work from last year, is that most previous work relies on syntactic information. The systems that operate on the parse tree, of course, they can only handle the parse tree, and they can only produce a compression out of that. But the systems that work through sequence labeling, usually they use the parsing as very important features in the model, the dependency edges. And the problem we found is that we were training all of these on news. We were trying to apply them on web data. And then when you go to web data, you have lots of cases where people didn't write punctuation, where people write ungrammatical sentences. And whenever there is something like that, the parsers fail completely. And if the parse tree is wrong, then a compressor system operating on the parse tree cannot do anything at all. It can only garbage in, garbage out. It cannot do any grammatical compression out of that. And so we had this problem with out of domain corpora. It was very clear for web data in particular. And the question we had is, can we build a robust compression model relying only on tokens? And that's when we thought we'll give it a try also to LSTM, to recurrent neural networks. So the system is the following. We use as input the sequence of word embeddings from the sentence. So we take the original sentence, and for every word we have an embedding vector that you can produce through distributional methods using word2vec or some similar approach. It's just a very dense vector that is encoding somehow the meaning of the word. And then we use a 3-stacked LSTM system. In principle, if you put a few more layers, you can allow the system to go to a higher abstraction. And then the output was just a softmax, only 2 classes. So it's just a logistic classifier deciding whether to keep or whether to drop. And this is how it looks at training time. We give as input the reversed original sentence, so the original sentence in reverse order, and this is a standard practice now for all these LSTM methods for machine translation and parsing and all of these approaches. People realize that it is empirically better if the sentence is provided in reverse order. There are intuitive explanations for that, but we don't really understand what is happening inside the network, so it's only intuitive. But what you can think is that the LSTM, in every cell internally, it has some logic. It has 3 neurons in every cell where it's keeping a state, and then it's deciding at every step whether to how much importance to give to the internal state and how much importance to give to the input. And then it produces the output out of that. through 3 different neurons. And then, so it trains a weight matrix that, depending on the input and the state, it can decide whether to continue remembering what it knew from before, or forget completely about it and consider only the input and move on from the current input. And then in this way, it can remember some long-distance dependencies. It can sometimes have this long-term memory where it remembers things that come from very far away in the past. But of course, the farther away it is in the past, the lower the probability that it is remembering that. So the intuition is that if the sentence is produced in reverse order, it will remember more often the last information about the last tokens that came, which are about the beginning of the sentence. And then once it starts actually working and producing the predictions, it has more memory about the beginning of the sentence and it can reason better about it. This is the intuition, but as I said, we don't really know. So, and then after giving the sentence in reverse order, we give a special symbol, which is to indicate that the sentence has finished, and then we start giving again the same sentence in the correct order. And now for every token, it has to make a prediction, this binary prediction. Should we keep the token or should we drop the token? And because we provided the sentence before, it already has an internal state that allows it to make the decision about the first token. So it already has the context about what the whole sentence looks like, and then it can decide what to do with the first token immediately. So with the same example sentence as before, if the first token is 32-year-old, we have an embedding vector for that token. So we have like a 200, 300 dimensional vector there that is provided as input. And then an additional input was the last prediction that we made. And this is because if you look at the training data and the real compressions, quite often, it happens very often that it keeps many tokens consecutive and then it drops many consecutive tokens and so on, because it may be decided to drop a relative close. So then there is a long sequence of drop decisions, and then it may decide to continue with the predicate, and then there is a long sequence of keep decisions. So keeping into the memory what was the last decision seems to be an important feature to take into account. So this is the input layer, and then the network produces the activations for all the nodes in the 3 LSTM layers, and finally it makes a prediction. So let's suppose that it decides here to drop this first token, that the probability of dropping is higher than the probability of keeping. We move to the next token. Now we have the embedding of the next word, like biker. And this additional feature tells us that the previous token was dropped. And now we make the predictions, and now it may decide, for example, to keep this token. And then we move on in this way. And of course, you can use this greedily, taking the highest probability prediction at every step. You can also use a beam search if you want to explore a bit more of the space. Now, this is a model that has absolutely no reliance on syntactic information at all. What we wanted to try is, many people have used syntactic information in sentence compression before. So there is the question, if we put syntactic information, is it really going to help, or is it not really needed here? So we had a second setting in which in the input we provide the embedding vector of the current word and the head word in the parse tree. So the head of 32-year-old is the word biker, the head of biker is the verb rescued. So we provide the two vectors in case knowing about the head word, whether it helps to decide whether to keep the modifier or not from the parse tree. And then finally, the last setting that we used to give even more additional information based on syntactic features is this 3 vector is a one hotspot vector where we consider 3 different cases. The first bit is telling us whether the parent node of the current word came before and was dropped. So if we decided to drop a verb and then later we see the direct object, most likely we want to drop the direct object as well. The second case is if the parent came before and was retained, the opposite case. And then the last case is whether the parent is coming later in the sentence, so we haven't seen the parent yet while doing this decoding left to right. And let's see the results. So the baseline is this. The baseline we've used is a sequence labeling system. That's this Myra system from Ryan McDonald. We used it as baseline because it's sequence labeling, same as LSTM. We didn't publish, but we also tried with some state-of-the-art parse tree-based systems that we had published in the previous year. And I can also tell you the results about those later. But the results I have here are based on this Myra system. The system was modified to be a distributed implementation because at the time Ryan did his experiments in 2006, the biggest training data available for compression was tiny. It was only hundreds or at most thousands of parallel sentences, whereas we have 3 order of magnitudes more training data. And that means that Ryan, for example, he couldn't use a lexicalized model. His model was based only on part of speech tags and dependency labels, okay? So we modified it to be able to use lexicalized features to have distributed training. And then if you look at the results, the LSTM is much better across all the metrics. Token-based metric and sentence level accuracy and compression ratio is comparable, is basically the training set compression ratio. We did also manual evaluations, and LSTM is also better than Myra across all the metrics, readability and informativeness. Some interesting cases of wins and losses. Most of the losses are coming from cases where an extractive compression is just not good enough. If the system in this case decide that the important entity was Gwyneth Paltrow, and the right compression is to say that Gwyneth Paltrow is separating and Chris Martin is dropped, the verb has to be reinflected to be put in singular case, and that's something that an extractive system is not doing. Or another pattern of losses is like this, sentences where we really shouldn't drop anything. If you look at this original sentence, whatever you drop, you're changing the meaning. But then the system is trained on this parallel data, and it actually learns that you can compress almost everything. So it tries to be very proactive in compressing. And examples wins are nice in that you can see, like, for example, in this case, you can see that it really extracted little pieces from all around the sentence. Meda Patkar extended her support to a MADMI party. So it's keeping and retaining many different tokens in between. And this is another case where you have a very long distance dependency where the system has dropped the whole relative clause, as I say, without having any syntactic features, but it has decided to do that. Now I have to finish, but just to finish, to compare with using the syntactic features, using the automatic evaluations, using the syntactic features seem to improve a little bit, particularly on sentence level accuracy. But then once we went to the manual evaluation, they actually become slightly worse. It's not statistically significant. So we think all the LSTM systems with and without syntactic features are about the same. Our explanation is that using the syntactic features, we're actually overfitting some aspects of the training data because the training data has been produced in this way from news, and it has some regularities, and it's learning these regularities. But when applied to general web content and doing a manual evaluation, this is basically overfitting, and it's something that's not really helping. So just to finish, some takeaway messages I wanted to give here. First of all is that NLP is a thriving area at Google and everywhere else I look around. So this is the golden age for NLP, in my opinion. And many things are receiving a lot of investment, many areas, question answering, personal assistant, dialogue, internationalization, all of these are very, very hot topics for us. And Google tends to target applied research that can be either long-term with potential for high impact, but with the condition that it has to be possible to track the progress. We don't want to invest on something that is long-term, a 3-year effort, and we will not know until 3 years from now if we really made progress or not. And also short-term, things that can be subdivided into smaller steps with immediate applications. And finally, almost all, not everything, but a lot of things we are doing right now are really based on deep learning. So for us, it's been a very big revolution that's led to to big improvements across all the metrics for many different NLP applications. Thank you.
So thank you. I think we have a lot of questions from the audience. So.
So what is the ratio between the number of linguists and philosophers versus the number of engineers and computer scientists in your group?
So we have an organization of linguists now who are helping for corpus annotation and for many other tasks. In Zurich in particular, so the linguist managers are based on the main Zurich office, sitting together with the engineers. But then we have, for example, in Milano, we have a team of linguists, particularly for Italian. They're working from the Google office in there, being managed by Silvia, who is in Zurich, working with us. And there are some linguists also in Madrid, in Paris, in Germany, in other places, managed from Zurich. So all in all, in Europe, I said if you consider all of this together, in Europe probably there are more linguists than engineers. If you consider worldwide, then then there are probably many more engineers than linguists.
I have the mic now. Thanks for the great talk. I would have several questions. So one question is that a few years ago, you had different slides, and everything was converted into the MapReduce paradigm. I'm wondering if you have now some connection between neural nets and MapReduce, so that you are trying also to exploit MapReduce architecture with neural nets.
So for deep learning, Google now uses this TensorFlow implementation that was open source recently, maybe a month ago or so. Yeah, there are connections with MapReduce as well. I'm not so familiar internally of the internals of it, but we use distributed implementations of it for it to be much faster in training with very large data sets. Yes.
And second question, and last question. I mean, I was interested by this application of summarization, which reflects a bit also problems that you can face with machine translation. So one point is you never talk about training data because it seems quite expensive to gather the necessary large amounts of training data. So you have any, can you tell us a bit about how you collect sufficiently amounts of training data for this task?
That's very much application specific. In a case like this, I explain how we collected the training data from news. It's also, if we go to a different domain, it's also possible to benefit from the linguists to do manual annotations for us in the domain that we are interested on. And then it's a matter of doing the domain adaptation when we have data that we have collected automatically. So we may have very large amounts of that. And then domain-specific data that has been done manually. So we have a very small amount of that, and how to train a model that can benefit from the large amount of semi-supervised training data that we know is not really about the domain we care about, and then doing the domain adaptation, leveraging the manual data. So most of this is still an open question, how to do that in the best possible way, but this is the kind of directions we follow. Right.
A non-technical question. You mentioned that you do often change your technology. You adapt your technology when you see some new ideas coming, and then you incorporate in your developments. Now the question is, how do you deal with intellectual property rights? If somebody invented something that wasn't built by you, what do you do? You buy the patents, and you.
Well, if there is some so if there is some technology that we see we really need to use, because it's going to improve our systems, and someone else holds the intellectual property, so we try to license it. We also have, it can be either an idea, a technology, a patent. It can also be corporate resources. So if we identify something that's going to be helpful for us, then we try to license it, yes.
I'm sure there are a lot of more questions from the audience, but time is tight. Sorry about that. We have a lot of talks about, I really want to thank the invited speaker to give us this really entertaining work.
Thank you very much. Thank you.
Sì, sì. Ok.
Daniele Bonadiman. Daniele Bonadiman, ok.
Slide 2.
Allora mi lasci, sì, ok, grazie. Okay, now we start the session about information extraction and information retrieval machine translation. Okay, I'm the chair, Ioanna Monti from the University of Sassari. And now I introduce the first talk, Deep Neural Networks for Named Entity Recognition in Italian, by Daniele Bonadiman, Alexei Severin, and Alessandro Moschitti. And the presenter is Daniele Bonadiman. So.
Good morning to everyone. I'm Daniele Bonadiman, and I'm happy to be here to present our work on a deep neural network for named entity recognition in Italian. Well, the task of named entity recognition is the task of detecting phrases in text that directly refers to real-world entities and categorize them with a type. For example, in the sentence, Barack Obama needs to be categorized as a person and Stati Uniti as a location. The task can be solved using rule-based approach, but in the recent years has been solved as with a statistical approach, in particular as a sequence labeling task, where you need to assign a label to each word in the original sequence. In order to do that, you need to use the Yob tagging schema, and in particular for the first word of an named entity, you need to assign a begin tag, and for the other words, you need to assign an inside tag to detect the boundaries of the named entities. And you combine these tags with the category tags for the named entity in order to produce the final sequence labeling task. As said, the named entity recognition is usually solved using statistical approaches. In particular, has been solved with combination on various machine learning systems, as in Zanoli and Pianta, Nguyen et al., or Flornia et al., or using large set of manual engineered features, as in Ratinov and Roth of 2009. From 2011, a deep learning approach has arisen, as in the case of Colbert and Weston, that presented an end-to-end deep neural network for named entity recognition. The simplest way to annotate a sequence is to use a sliding window approach, in particular a context window approach, where you fed as input to a classifier a set of words around the word to tag. In particular, if you want to annotate the word ill, we are going to pass in input to the classifier 2 words on the left or 2 words on the right, or whatever the window size that we think it's needed. However, these kind of approaches do not model dependencies on the output sequence. In particular, the classifier is not aware is not aware of the label that has already produced by the network in the previous stages while processing the sentence. In order to address this task, some approaches has been presented. As in the case of CRF, it's possible to model the dependencies using Viterbi decoding, or as in the case of Colbert and Watson, they produced a sentence-level log likelihood that uses Viterbi decoding to produce a log likelihood of the whole output sequence. However, we think that for different reasons that I will explain later, that a simple feedback loop is enough to obtain a good result in named entity recognition in Italia. In particular, the feedback loop we proposed uses another set of features in input of the network, in our case, it's a network, on the classifier, that are aligned with the words, and they are the output of the classifier at the previous stages. This approach is simple and may produce error propagation issue, but as we will see later, this using a neural network to model this kind of feedback loops is possible to reduce this kind of error propagation issue. The recurrent neural network is based on the Colbert and Watson one, and in particular, we are going to use as input of the network a context of word around the word VI that we want to annotate, and we fed them to the network. Words are then mapped to word embedding via simple lookup operation. And in the same way, it's possible to add additional feature. As in particular, in our case, we are going to add as embedding the tags of the previous stages of the network. And we are going to use this, we are going to train this embedding with another weight matrix, not the same of the words. And then these word vectors are concatenated and fed to a hidden layer. And this layer performs a linear transformation of the input space and followed by a nonlinearity. In our case, as in the case of Colbert and Watson, is an earth and age. The produced vector is then fed to the output layer, and that can map via softmax to that model via softmax probability scores for its tag given the input sequence. The network is initialized with random weights and trained via stochastic gradient descent using backpropagation. And by doing so, the weight of the network are adjusting according to the contribution to the final loss. However, it's possible to train different kind of models as a convolutional neural networks or recurrent neural network that performs this the feedback loop on the hidden layer. However, for Italian, there is not enough data to train this model without having overfitting or and for this reason, even for training our model, we needed to have more data. In particular, we used a weakly labeled dataset that is a dataset composed of articles taken from the local newspaper L'Adige, automatically annotated using an off-the-shelf named entity recognizer. This dataset is in our experiment. We then pre-train the network on this dataset, and then we train the network on the actual dataset, manually annotated. We evaluated our network on the Valita 2009 Italian dataset that is composed from articles taken from the local newspaper L'Adige, and manually annotated in four different named entity types that are person, organization, location, and geopolitical entities. Moreover, we initialized the network word embeddings with embeddings pre-trained on the Italian Wikipedia using the script gram model of Nicole, that is the word-to-vec model. And by doing so, it's possible to embed in the network some semantic and syntactic information about the word itself. And in the evaluation, we used as a baseline a simple context window network, that is the one that we proposed without the feedback loop. And as you can see, by adding this simple feedback loop, it's possible to train 3 points improvement in F1. And moreover, by training on the weakly labeled dataset before, it's possible to have a small improvement in tenfold class validation. But this small improvement is more important to notice that between the various, on the iteration on the various faults, the results are more consistent, and they are less prone to overfitting by doing weakly labeled, by using the weakly labeled dataset for pre-training. Moreover, we decided to add the gazetteer feature because it's a well-known and used feature for name identity recognition. And adding the gazetteer feature, in fact, is possible to obtain other 2-point improvement. We then evaluated our model on the between the Valita 2009 system, and it's possible to notice that our model met without feature engineering, so without the gazetteer, met the result of the competition, obtaining 81.42 in F1. But adding the gazetteer, we are able to obtain better result than the Valita one. However, Nguyen et al. Presented another model in the recent years that uses a ranking strategy using three kernels on top of their result. We're using CRF at the competition, and they obtain 84 in F1. However, we do not directly compare with this model because we think that applying the same ranker on top of our model is possible to obtain a comparable, if not better, result. In conclusion, at best of our knowledge, we propose the first model for Italian identity recognition that uses a deep neural network. We proposed a feedback loop to efficiently model dependencies over the output sequence, and a pre-training technique that involves a weakly labeled dataset in order to avoid overfitting and have a good generalization. Finally, the system proposed is rather simple and efficient. In fact, it only involves one model at test time. There are not too much feature engineering, nor extensive data processing. In fact, I can train the model on my laptop in a bunch of hours, and at the end, it can produce on my laptop annotation for sentences in a few milliseconds. Thank you to everyone, and if you have questions.
Okay, thank you for being. So, questions? Okay.
So you mentioned that in training you do statistical gradient descent, but the work by Colobert uses a much more complicated technique, which is to use a recursive overall backpropagation technique. Did you consider that, or?
No, I use a simple stochastic gradient descent by considering each window independently. Each context windows is considered independent as an independent example. In that way, I have a more independent, I would say, independent examples, and then it's possible to train the network more efficiently and more fast, I would say. The sentence level log likely. Yeah. Yes. Yeah, it may improve. However, we think that for the Italian language, I did some experiment on that, and for the Italian language, we tried even convolution and some recurrent technique as LSTM and simple recurrent neural network. However, this more complex model, in our case, are more prone to overfitting, and they are more slow to train. And we think that in our case, even if since the task of identity recognition is usually part of other pipelines, having an efficient model, fast and efficient, is a requirement.
There's actually no loss in performance if you train a sentence level likelihood, because it uses the rubbing technique, which does everything in one stage, step. So there's no loss in performance in training.
Okay.
And then in prediction, it's still just one goes once through the layers of the network. So there's no loss at all. It's just a different technique during training,
Yeah,
but you don't.
But at the end, you need to apply Viterbi decoding to produce the output sequence.
Yes.
Yeah, and is a trade-off to have.
But it's also linear, right? Viterbi is also very fast.
Yes, for sure. We can try to add on top, but we think that the result will be we already obtain a good result using this simple feedback loop, and we think that applying the whole Viterbi decoding, in particular, having this kind, we found that having this kind of embeddings for the tags is possible to mitigate the problem of error propagation issue, because the idea of having the whole decoding of the whole input sequence is to reduce this error propagation issue. That is, if I misclassify the first tag in the sentence, in the next stages I will have some misclassifications. By having these word embeddings instead of feeding some discrete feature directly, we found that this error is actually mitigated. The network is going to recover from the error.
Okay, there is another question.
Do I have time? Okay.
Yeah.
I have a question, a clarification question on your results.
Yeah. Yeah.
So you improve on Gizmundor, significantly by adding the gazetteer VAV, whatever WLD is. So the question is, did he already have this extra data sets in the model, which, if I remember correctly, was a bidirectional tagging model?
Well, what? Sorry?
I'm looking at your F1 column.
Yeah.
And I'm looking at the different numbers of the previous methods, which you beat only by adding this extra data and extra information. So the question is, do the other models you're comparing to have these
the other model doesn't have the weakly labeled data set, but they have the gazetteer feature. I think I'm pretty sure that all of them uses gazetteer because it's a well-known feature, and it's always improved.
But then the fair comparison is to see what they would do with the weakly labeled data, because otherwise we are left with a doubt that that's what gives you the added value that they would have gotten too. Right? So if this is a comparison of the method, you need to leave everything else equal.
Okay, probably we are going to have more result, and we can compare with other baselines too.
Okay, now I think it's time to move to the second talk. Thank you. Okay. So, it's okay? Okay. New wine in old wineskins, a morphology-based approach to translate medical terminology by Raffaele Guarasci and Alessandro Maesto, and the presenter is Raffaele Guarasci. Okay.
Buongiorno, io preferirei parlare in italiano anche per un fatto di tempistiche. Il lavoro che presentiamo è un lavoro sulla morfologia, in particolare se è possibile applicare un tipo di approccio morfologico nella traduzione della terminologia medica, quindi un sistema di un dominio estremamente ristretto. Esistono ovviamente, sono stati sviluppati nel corso dell'ultimo decennio una serie di approcci simili, sia sulla decomposizione morfologica, sia sulla automi a stati finiti per la traduzione, in particolare con ECD10 o SNOMED sono stati fatti vari tentativi con risultati alterni. In particolare il nostro approccio sfrutta i confissi, quindi gli elementi formativi neoclassici. Gli elementi formativi neoclassici hanno una lunga tradizione e sono di fatto morfemi con un valore semantico pieno che derivano da radici greche o latine che si combinano tra loro tramite regole morfologiche e hanno la caratteristica, cosa più importante, di essere semanticamente autosufficienti. Perché il dominio medico, in particolare un sottoinsieme del dominio medico che è la terminologia relativa alle malattie rare, perché è di fatto quasi completamente composto da confissi con vari livelli di complessità e varie regole combinatorie. Qua nell'esempio acrocefalopolisindactilia, banalmente, è uno dei casi più estremi in cui la decomposizione morfologica dà chiaramente non solo il significato, ma anche i vari domini di appartenenza. Il nostro lavoro è stato articolato in due fasi: la creazione di una risorsa lessicale, in particolare un'ontologia di morfemi, partendo dall'idea che sono sufficienti pochi, un insieme molto piccolo di morfemi per descrivere un numero estremamente vasto di termini. Poi sono stati suddivisi nelle 22, diciamo, con l'aiuto di un esperto di dominio, nelle 22 specializzazioni mediche, e sono stati annotati con proprietà sintattiche e proprietà semantiche. Sintattiche come confissi, suffissi, per questo ci siamo avvalsi dell'uso di Gradit, che è la versione elettronica, e proprietà semantiche come la classe di riferimento, il sottodominio e l'aggiunta poi ovviamente del corrispondente morfema nell'altra lingua. Al momento poi è stato creato un prototipo di sistema di traduzione basato su traduttori a stati finiti. Al momento funziona italiano e inglese. Abbiamo testato anche sullo spagnolo, però ancora i risultati per motivi poi di tempi non sono stati presentati. E abbiamo testato il prototipo su Orphanet in particolare. Orphanet, che è un database di malattie rare o malattie estremamente rare, e ovviamente italiano e inglese, avvalendosi della valutazione usando gli standard ICD-10 e in alcuni casi UMLS, e i risultati sono stati estremamente alti. Abbiamo confrontato con i più diffusi sistemi di traduzione, in particolare Google Translate, che è traduzione a ampio spettro, BubbleNet e i top, che hanno un aspetto, soprattutto i top, più di dizionario controllato sulla terminologia biomedica e clinica. I risultati sono stati molto alti, però è ovviamente da tenere presente che è un sistema che è addestrato solo in questo dominio estremamente specifico ed estremamente ristretto. Non pretende di essere un sistema che funziona in una traduzione generica, come invece sono Google o per alcuni aspetti anche BubbleNet. La cosa interessante, anche perché il lavoro è stato un lavoro nato per caso da una costola di un lavoro più ampio sulla morfologia, sono alcuni risultati emersi, in particolare che un approccio morfologico in alcuni casi può funzionare, per esempio una dichiarazione un po' da prendere con le pinze, bene quanto un sistema probabilistico in un dominio estremamente ristretto, ovviamente. Perché la traduzione fornita è più vicina, più consistente con quella dello standard, cosa che solitamente non avviene con Google Translate, ad esempio, in quanto tantissime volte traduce il termine correttamente, ma con un termine più generico, cioè un termine nella tassonomia superiore, che non è un errore in un contesto normale, ma in alcuni casi specifici, come il caso dei trasfrontalieri nel cross-border healthcare, lisinemia e iperlisinemia, cioè, non è la stessa patologia, mentre Google tende a generalizzare. Soprattutto questo si vede moltissimo nelle malattie, più si va a fondo nello standard, nelle malattie estremamente rare, più è generalizzato con la patologia generica. Un'altra cosa evidenziata è che non sbaglia mai quando tutti gli altri sbagliano, anche perché tutti gli altri sbagliano perché danno il termine generico, oppure in alcuni casi banalmente nel caso delle malattie rare non esiste il corrispettivo. Un effetto collaterale è che funziona, e questo è un test su un corpus preso dalle diagnosi, un set di diagnosi della Regione Campania, le cartelle cliniche della Regione Campania, funziona come correttore. Sembra una cosa banale, però in realtà nelle cartelle cliniche tantissime volte ci sono errori di battitura. Sistemi testati come BubbleNet, IDOP, Google, se si sbaglia a scrivere anche una sola lettera, ovviamente non traduce nulla, restituisce la stessa parola nella lingua di input, non traduce semplicemente. Un approccio morfologico invece, scomponendo il morfema, mette il morfema corrispondente nell'altra lingua e quindi in realtà lo corregge. Ha senso nel caso di dati non controllati, ovviamente. Per ora è rimasto, diciamo, un esperimento un po' work in progress, però ha evidenziato alcuni aspetti interessanti, soprattutto come strumento di supporto sia come integrazione ipotetica in sistemi probabilistici, oppure come supporto in traduttori umani, anche perché nell'ambito del dominio medico tantissime cose vengono comunque controllate e quasi sempre c'è l'esperto di dominio che controlla a monte, anche per un fatto proprio di coerenza con lo standard. Come ho detto prima, anche nel caso di cross-border healthcare, qui per esempio, vedo adesso c'è un errore di battitura healthcare, che manca la H a seconda, e questo il sistema l'avrebbe corretto, quindi non avrebbe fatto errore. Un esempio di applicazione. Quindi sarebbe stato... oppure negli standard, perché tutti gli standard medici non sempre sono allineati. Orphanet, ad esempio, che ha un... summary di tutti gli altri standard, ha spesso non sempre ha i codici per tutti gli standard, ovvero non sempre c'è una trasparenza. Da ICD-10 inglese di Orphanet non si risale per forza a ICD-10 italiano corrispondente. Non sono le tassonomie, non sono quasi mai allineate completamente. Grazie.
Okay. Any questions?
Okay, such approach, I mean, works or presupposes that there is total transparency of the morphemes. Okay, and this is quite likely in a technical domain like medicine. But have you experienced where there are cases in which this principle is violated even in a technical domain, and so you can have some false positive in your segmentations or your morphemes that are, or words for which the morpheme decomposition or the morpheme composition is not totally transparent any longer?
Yes, because in some cases the meaning of the medical, even on a medical disease or medical word, is not derived from the morphemes that compose the word. Yes, they are, but in particularly on rare diseases, the vast majority of words are the meaning of the vast majority of words are almost fully derived from confixes or morphemes.
Tu hai detto che sbaglia poco dove gli altri sbagliano molto.
Sì.
E poi hai detto che fai il 91%. Questo 9% di errori, quindi, che più o meno come lo hai classificato?
Sono i termini in cui il significato non è desumibile dalla decomposizione morfologica, oppure errori nelle regole di composizione, banalmente, casi non considerati. Per questo si è scelto di fare, ad esempio, solitamente l'approccio in questi casi, l'approccio classico è quello di un dizionario. Per questo si è scelto, diciamo, un'ontologia, in modo anche da poter estenderla in modo meno computazione, con meno costo temporale e più elastico. Sì.
So maybe we have time for some more questions. Yes. Okay. Please.
Hai detto che il significato risulta dalla decomposizione morfologica. Sì. Ci sono dei formativi neoclassici, come ad esempio logo, che possono comportarsi sia come testa che come figlio. Non so, filologo in un caso, oppure ematologo nell'altro. In un caso è l'amante del logo, sì, nell'altro è lo studioso del sangue. Come gestite queste cose? Cioè, nel decomporre, identificate anche la testa, i dipendenti, eccetera?
Sì, in realtà sì, anche se nel fatto essendo essenzialmente uno strumento di dominio medico, l'ambiguità è estremamente ridotta in questi casi.
Ok. Any more questions? No? Ok, thank you. Grazie. No, scusi. No.
Just a curiosity, because during the composition, we just keep the same order, we have to do some reordering. Scusa, durante la ricomposizione devi fare un riordinamento dei morfemi, oppure sono sempre nello stesso?
No, vengono riordinati.
E quello con che criterio?
Dipende in realtà. Abbiamo estratto una serie di pattern sulla frequenza con cui si combinano i tipi di morfemi. I morfemi sono stati divisi a monte secondo suffissi, confissi, prefissi, quindi analizzando da un campione di ICD-10 i più frequenti tipi di combinazione, dei pattern ricorrenti di come si combinano, quindi delle frequenze di combinazione, una sorta di profilo distribuzionale della combinazione dei morfemi.
Ok, va bene, grazie. Ok, the next talk is la scrittura in emoji, dizionario e traduzione, by Francesca Chiusaroli.
Grazie. Il 30 luglio del 2015 abbiamo detto addio a Emoji, il primo social network dedicato esclusivamente alla scrittura in emoji. Gli autori hanno dichiarato che non è stato possibile proseguire il progetto perché troppo pochi gli accessi, troppo poche le interazioni. E l'abbiamo salutato, mi do del noi insieme, diciamo al blog Scritture Brevi, sperando di rincontrarlo dal momento che io facevo parte di quelli che si erano iscritti. Questa esperienza ci ha ricordato che non può esistere sussurianamente la parole senza la langue, cioè un messaggio senza un codice. L'odierna popolarità degli emoji negli ambienti digitali non trova di fatto un riscontro nella pratica razionale. Tutti i giorni leggiamo dichiarazioni in rete sull'avvento del nuovo idioma in emoji. Evviva, abbiamo un nuovo idioma in emoji. Aiuto, abbiamo un nuovo idioma in emoji. Il pubblico della rete si divide tra il sì e il no, ma nessuno in qualche modo riflette su che cosa è successo. Personalmente ero già bloccata all'ingresso, all'iscrizione che prevedeva di scegliere un emoji o una sequenza di emoji che rappresentasse la persona. Tanti insuccessi sono richiamati dalla tradizione in questo senso. Nel 1600 nella Royal Society molti progetti intendevano inventare un idioma fatto di scrittura che prescindesse dalle lingue. Ed era già chiaro a quell'epoca che questo non era possibile. Questi sono i cosiddetti emoticon, cioè le espressioni del viso, e in questo senso possiamo considerarli degli elementi che hanno acquisito una alta capacità disambiguante, poi anche su questo potrei dire delle cose. Non è però così per la tastiera degli emoji, che chi scarica le applicazioni, cioè gli aggiornamenti, vede che si arricchisce continuamente di nuove immagini, ciascuna corrispondente a dei realia, in pratica scrittura. Qui vedete l'unicorno, per esempio, molto atteso, di cui si sentiva il bisogno. La mia prospettiva parte da una proposta, ovvero proporre alcune riflessioni linguistiche per valutare l'ipotesi di una collocazione degli emoji nella prospettiva di un codice veicolare normalizzato, per la capacità di porsi quale segni di un sistema intermediario, eventualmente automatico per la traduzione multilingue, attraverso un procedimento di trasferimento e applicazione di valori semantici comuni, generali, condivisi, secondo un metodo di pianificazione metalinguistica a posteriori, ovvero abbandonando l'idea di creare una lingua dal nulla, prescindendo dalla lingua. Al contrario, utilizziamo la lingua, le lingue esistenti come codici veicolari. La funzione codificatrice dell'intermediazione linguistica può provvedere alla prioritaria assegnazione di valori logografici alle figure, con speciale efficacia nei contesti traduttivi. Il disegno, che visivamente per la pregnanza pittografica rinvia a un'ampia sommatoria di valori semantici, può acquisire attraverso lo strumento traduttivo significati convenuti, fissi, linguistici prima, poi logografici, consentendo la fissazione di corrispondenze utili all'impiego degli emoji secondo un codice convenzionale, condiviso e finalmente internazionale. Alcuni passi sono questi, cioè stanno già avvenendo, dei dati già li abbiamo, l'inserimento degli emoji nello standard Unicode, che ha trasformato finalmente, che sta cercando di trasformare quel odioso quadratino bianco che non è comprensibile addirittura da sistema operativo a sistema operativo. Abbiamo la Emojipedia, cioè una Wikipedia degli emoji, cioè un grande dizionario universale, poiché Wikipedia, l'idea sarebbe questa, un grande dizionario universale dei referenti corrispondenti agli emoji distinti per categorie lessicali. Abbiamo esperimenti, come vedete, questo è l'esempio di Emoji Fortunes, cioè noi possiamo tirare fuori 3 emoji che hanno, attenzione, una traduzione in inglese. A partire da questa traduzione, ma anche l'esempio precedente è tale, cioè noi abbiamo già una corrispondenza fra emoji e lingua inglese, che però non vuol dire avere, diciamo, una corrispondenza universale. Qui è quando passiamo dal valore, diciamo, di categoria generale al valore di categoria grammaticale, ed è un passaggio necessario quando noi ci riferiamo all'emoji come un elemento che deve andare a costruire un testo linguistico. Quello che prima troveremmo come concetto della lampadina, vedete che qui diventa un verbo. Capiamo che è un verbo dal contesto. Questa è una serie di piccoli esempi di un esperimento che è stato fatto appunto su Twitter da scritture brevi, che si chiama In Emoticon, di traduzione, che come vedete è un gioco, quindi è alto il livello di fantasia, di creatività ludica, però ci ha dato degli elementi e soprattutto un utilizzo della scrittura mista, lingua e figura. Ma anche qui nascono immediatamente problemi. I problemi sono le omografie, le omonimie, le sinonimie. Tutto questo non può, va contro, diciamo, il percorso verso la scrittura condivisa. Odi et amo, dove et, ok, vabbè, questo di fatto, cioè la grande creatività dà anche grandi possibilità di idee. Esatto. Va bene? E questi appunto sono continuamente nuovi aggiornamenti. Voi vedete per esempio chi usa gli emoji sa che sono classificati dentro dei contenitori, quindi noi trovando queste dentro ci troviamo per esempio le varie coppie, cioè questo è SwiftKey che fa il report sull'uso per esempio etnico, nazionale, geografico, cioè collegato alle specifiche etnie, perché non dimentichiamo che uno dei problemi che hanno avuto sempre gli inventori di lingue universali sono quello di incontrarsi poi con le specificità della lingua. Questo è l'esperimento di The Guardian sulla traduzione in emoji dei discorsi di Barack Obama, emoji Obama, e questo è esattamente un problema del, diciamo, anglocentrismo, come potremmo chiamarlo. Anche qui scrittura mista, questo si legge will we accept, cioè dove we è noi americani, quindi è un we che... utilmente questo sito mette a disposizione una traduzione, una lettura, cioè strisciando col cursore sopra l'emoji abbiamo la traduzione, quindi noi questa traduzione l'abbiamo, ma certo se dovessimo usare le stesse forme per tradurre gli stessi discorsi in italiano, noi poi cioè saremmo in difficoltà a scegliere la categoria del we agganciandola alla bandiera americana, o meglio in questo contesto ci va, ma bisogna poi, diciamo, tassonomizzare anche le categorie. Questo è l'esperimento Emoji Dick, cioè l'intero libro di Moby Dick tradotto in emoji, dove c'è un fortissimo, dunque si tratta di una traduzione di gruppo, crowdsourcing, praticamente 800 traduttori hanno tradotto ognuno 3 volte la stessa frase, poi un altro gruppo ha votato la frase migliore e praticamente vedete che è fortissima la sintesi, l'effetto di sintesi, così che diventa impossibile. Ci ho provato a usare questo testo come un testo mediatore, perché noi abbiamo la traduzione italiana di Moby Dick, quindi è interessante vedere che cosa diventano questi emoji nel momento in cui vengono a tradurre il testo italiano. Questo è un poster che traduce interamente Alice nel Paese delle Meraviglie in emoji, totalmente in emoji. Sia per Moby Dick volevo dire che comunque la soluzione adottata è il testo interlineare praticamente. Questo è sempre un esempio di Alice nel Paese delle Meraviglie. L'autore chi si è occupato della traduzione di Moby Dick è Fred Benninson con un gruppo, poi possiamo anche aprire il sito, se volete sta lavorando a un traduttore automatico, e questo è un esempio di traduttore automatico. Conosciamo per esempio esperienze medievali di traduttori che rendono disponibile frasari relativi all'esperienza pratica quotidiana. In questo senso vedete che quello che succedeva su Emoji Dick non succede più qui, perché qui è più di base la traduzione. In questo senso questi tipi di testi possono essere usati come base per una traduzione da lingua a lingua. Ho finito e concludo, quindi. Il richiamo alla corrispondenza bionivoca appare come l'elemento più significativo per un metodo che intenda considerare gli emoji non soltanto quali elementi dell'atto di parola, unico, idiosincratico, bensì come segni di un codice formalizzato e condiviso, il più possibile coerente, univoco e razionale. Al di là della dimensione creativa, oltre la vaghezza e l'equivocità dell'uso individuale, l'ipotesi della scrittura in emoji come sistema veicolare deve consegnare alla pratica un codice idoneo alla comunicazione internazionale e multilingue. Un sistema dunque costruito da una preliminare selezione secondo un corretto equilibrio di coerenza ed efficacia, capace di riprodurre le idee, di ridurre, nel senso di reductio, la superficiale varietà per cogliere la struttura e il senso profondi. La priorità assegnata alla definizione dell'interlingua in emoji terrà in debito conto specificità e occasionalismi in quanto imprescindibili nell'atto comunicativo storicamente e culturalmente collocato, come tali inclusi nell'inventario secondo la prospettiva gerarchica delle relazioni semantiche formali, sintagmatiche e associative. Diverso ruolo sarà assegnato a significati non universalmente trasferibili o traducibili. Secondo un criterio tassonomico saranno collocati pittogrammi specifici allorché espressivi di valori storico-culturali peculiari e non di meno riconducibili alle forme di base, rispetto alle quali si porranno quali estensioni per aggiunta di elementi modificatori. Si tratta di un metodo peraltro già adottato nei sistemi di tastiera nel recente rilascio degli emoji relativi alla rappresentazione delle notazioni etniche, come il colore della pelle, i capelli, altre caratteristiche fisiche dell'orientamento etico e sociale, che stanno ampliando significativamente il repertorio predisposto, in tal modo abbandonando la cifra simbolica e adeguando la dimensione pittografica alla riproduzione sempre più fedele dei realia. Grazie.
Grazie Francesca. Any questions? Sì, c'è
una domanda. Non ha mai menzionato gli ideogrammi?
Sì.
Diciamo, che differenza c'è rispetto agli ideogrammi?
Ho parlato di logogrammi non a caso, perché il concetto di ideogramma diciamo che è un concetto che è un po' viziato dalla storia, cioè la rappresentazione dell'idea. Sappiamo bene per esempio che non si usa per il cinese più però il termine ideogramma, perché si usa carattere, perché in realtà che vuol dire, che cosa vuol dire riproduzione dell'idea? Se noi avessimo la possibilità certo di fare una lingua universale che prescinde dalle lingue, allora potremmo parlare di ideogrammi, ma abbiamo visto che non è così. Quindi io parlo di logogrammi, cioè di termini, di elementi che possono essere resi linguisticamente, perché non credo che non so se ci sia una dimensione esterna alle lingue reali per la rappresentazione concettuale. Però posso anche parlare di ideogrammi se siamo d'accordo. Questi qui per esempio sono i caratteri reali del saggio sul carattere reale di John Wilkins 1668, secondo una tradizione ereditata da Francesco Bacone. Lui parlava di caratteri reali ispirandosi alla scrittura cinese, che peraltro non conosceva, e sostanzialmente scindendo i concetti della realtà in 30 grandi categorie universali di tradizione aristotelica, e questo per esempio è una fonte di Leibniz, quindi il concetto di motore di ricerca si aggancia a questo, cioè costruire una rete di significati generali a cui si aggiungono poi le differenze e le specie, cioè connotazioni che vanno ad arricchire all'interno di un segno composto vanno a costruire effettivamente il codice linguistico. Ricordiamoci per esempio che in inglese si parla sempre di language, l'italiano distingue fra lingua e linguaggio. Questo non è una cosa di secondaria importanza, io credo, no? Quando noi parliamo di linguaggio tendiamo tante volte magari a dimenticarci della lingua, che però è con la lingua che facciamo i conti quando costruiamo i traduttori multilingue, o come potrebbe essere l'emoji. Adesso nel caso io tanto sono anche esperantista, per dire, cioè, mi piace tutto, quindi lo faccio perché mi interessa, ma sì.
No, io pensavo che una possibile area di applicazione poteva essere quella dell'uso di queste forme per chi ha bisogni comunicativi speciali. So che ci sono forme di comunicazione aumentativa alternativa, PEX, Avete mai fatto un'indagine magari comparativa tra questi simboli che nascono dal basso?
E per esempio per ciò che riguarda, ho citato soltanto en passant la questione dell'emoticon, perché per esempio quello può dare il significato prosodico di riproduzione dei toni del parlato, cioè dell'elemento soprasegmentale, in questo senso è disambiguante. Cioè, paradossalmente noi ci troviamo di fronte al fatto che davanti al disegno, cioè io che ero iscritta a emoji lì, parlavo con una persona a me estranea, inviavo, che potevo inviare? Cioè, potevo inviare qualsiasi segno, di solito si inviava un sorriso, ma al di là di quello non c'era un codice che ci permettesse di parlare. Quindi questo è grave, però se noi consideriamo la trafila che hanno fatto i sistemi scrittori, che hanno abbandonato le pittografie, perché le hanno abbandonate proprio perché paradossalmente il sistema grafico è stato più utile allora quando identificava un elemento, un segmento concreto che è stato identificato alla fine nel suono, prima nella sillaba, poi nel suono.
Domanda? Domanda è questa, nel senso, appunto, parte collegata a quello che diceva Dominique, no? Cioè, da un lato sembra esserci un vantaggio di alcuni di questi, diciamo, immagini, proprio perché possono veicolare aspetti che sono legati proprio a una chiarezza, diciamo, una trasparenza tra, diciamo, il significante e il significato da questo punto di vista. Però nel momento in cui questo si perde, sto pensando ai simboli che assumono una funzione grammaticale, tipo, ho visto alcune preposizioni per, e diventa per te, per indicare, quello è diventa un formato grammaticale da questo punto di vista. Allora, mi domando, non è che, come dire, nel momento in cui si trasforma in una lingua, come tale si perdono i vantaggi di un sistema di comunicazione che in fin dei conti avrebbe tutti i vantaggi di arricchire una lingua con elementi che sono paralinguistici, e che era in questo senso, cioè mi sembra quasi che ci sia, come dire, il rischio che trasformandosi in una lingua si perda il valore aggiunto.
Esattamente così. Io perché diciamo che collocandoci come un osservatorio in pratica dei fenomeni della rete si nota un grande movimento. Per esempio adesso la settimana scorsa è stata annunciata l'elezione di un emoji, quella che ride a crepapelle, come parola dell'anno dagli Oxford Dictionaries, che ovviamente è una provocazione, però qualche anno fa avevano messo il cuoricino, cioè un movimento in questo senso. Instagram poco tempo fa ha introdotto l'hashtag dell'emoji per evidentemente catturare gli umori, si parla di sentiment analysis, quindi per catturare gli umori, cioè io posso fare una ricerca con hashtag cuore, ci ho provato, quello che viene fuori è, cioè, il mondo ovviamente è molto molto vago. Gli emoji hanno questa caratteristica della riproduzione del reale, ma appunto nel momento in cui si è contestato il fatto che l'omino avesse i capelli biondi e allora quindi l'hanno fatto con la versione capelli neri, con la versione capelli lunghi, corti, ricci, lisci, è quasi una fotografia. La Finlandia ha fatto una campagna promozionale introducendo degli emoji personalizzati, cioè specifici per loro, tra cui l'uomo e la donna che fanno la sauna, e il Nokia 3310. Qual era? Il Nokia 3310. Se noi andiamo a vedere l'emoji predisposto dalla tastiera, tra l'altro è tutto meno che generico, però è un altro. No, non andava bene. Questo, cioè, io adesso lo propongo all'attenzione, perché diciamo che il mercato, quelli che possono essere, non so, comunque bisogni della rete e le nuove generazioni, non essere assenti di fronte a questi meccanismi che comunque di fatto si scontrano sempre con le specificità delle lingue. Pensiamo a come sia possibile tradurre le frasi idiomatiche. Adesso bisognerebbe andare nel dettaglio, per esempio, della traduzione in inglese emoji di Alice nel Paese delle Meraviglie. Lì sarebbe bello vedere, sì. Va bene.
Ok, grazie.
Grazie.
Quindi da programma coffee break.
On spoken language processing, morphology, syntax, and parsing. The first speaker is Paolo Dragone, that present an active learning approach to the classification of non-sentential utterances. Please respect 10 minutes, 12 minutes max.
Yes.
Thank you very much.
Can I start?
Shh.
Shall I start? Posso iniziare?
Sì.
Okay. Hi everyone, my name is Paolo Dragone, and my colleague and former supervisor Pierre from Oslo couldn't make it, so I will be presenting my work on classification of non-sentential utterances. So, non-sentential utterances are those utterances that do not have a complete form, but nevertheless convey a full meaning given the dialogue context. As in those examples, Sami is organizing a party where is a non-sentential utterance because it doesn't have a complete form with a noun and a verb, but we can understand its meaning from the previous utterance. So it is roughly where is the party taking place. But why are those NSU interesting in the first place? First of all, they are highly context dependent, and therefore they are ambiguous and difficult to interpret. In these examples, where there will be the party, Sunday. That's a short answer to a previous question. The party will be on Saturday, Sunday. That's a correction to something that was said before. And the party will be on Sunday, Sunday. It's an acknowledgement of understanding of a previous utterance. So we can see that the same exact utterance has different meanings given different contexts. Second point, NSUs are quite frequent in dialogue, and also they come in a large variety of forms and meanings. Fernandez et al. 2007 estimated the frequency of NSUs in the British national corpus to be about 10% of the total number of utterances, which is a good number. I mean, a good frequency. And they, in the same corpus study, they identified a taxonomy of 15 classes of different NSUs with different functions and forms. And with this taxonomy, they manually annotated a corpus, and with this corpus, they made a series of machine learning experiments for the classification of NSUs. So this is the taxonomy they used. We can see on the right the frequency in the corpus. And we can see some of the classes that we saw in the example as before, the short answers. For example, who left, Bo, meaning Bo left. So it doesn't have a predicate, but we can still understand its meaning. And another class that is interesting are Zlus, for example. Someone left, who, meaning who left. It is used to ask for additional information of something that was said before, in this case, about the person that left. So the classification of NSUs can be cast as a machine learning problem, and it is, of course, the problem of determining the class of the NSU given its context. And the context of NSUs can, in principle, include every variable in the dialog state, but in principle, I mean, in practice, it suffices to consider only the antecedent of the NSU, which is the preceding utterance that helps understanding the meaning of the NSU, as in the example we saw before. So for this task, the challenges that we faced regards mainly the structure of the data that we had. First of all, we can see that the label data is scarce because we have only few hundred instances, and the frequency of the classes in the corpus is very unbalanced, and it's largely in favor for some classes other than others. To make things more complicated, often it happens that the low frequency classes are also the most complex in semantics. For example, the most difficult class to predict are F for rejections, because are basically are strongly semantic, but we have only 24 instances. Instead, for example, plain acknowledgement, we have 600 instances, but they are the easiest one to classify. For example, okay, all right, yes, and so on. So to address those problems, we first of all, we did some feature engineering. We replicated the feature set of Fernandez 2007. And we added some more features. So the baseline feature set was composed of 9 features that were exploiting some syntactic and lexical patterns of the NSU, the antecedent, and the similarity measures between the antecedent and the NSU. To exploit the so-called parallelism at the syntactic and semantic level between the NSU and the antecedent. Instead, we added 23 new features for a total of 32, exploiting some post-level patterns, phrase-level dependency features using dependency parser, the turn-taking features exploiting the structure of the dialogue history, and some other similarity measure and numerical measures. So, but as the title says, we used active learning to face the scarcity of labeled data, which is the technique to manually annotate, that helps manually annotating the unlabeled instances, starting from a little bit of labeled data, as we had. We train a classifier. We classify a bunch of unlabeled data. The algorithm selects the most informative instance between those labeled data, unlabeled data, and the human annotator labels it, and the process is repeated again. So for us, the unlabeled data were easily extractable from the BNC using heuristics, and the AL process, the active learning process, was carried out with an SVM classifier. We used a pool-based technique with uncertainty sampling using entropy as a measure of uncertainty. Therefore, the maximum entropy instances was selected as most informative instance because it was simply the most difficult instance to predict. And in this way, we labeled 100 new instances that we used as additional training data. So the results show that the combination of these two techniques, the extended feature set and the additional training data extracted by active learning, led to a significant improvement over the baseline. And we can see this improvement in this table. In the first row, we have the baseline, and in the last row, the final approach using both the extended feature set and additional training data extracted by active learning. And it's a small but significant improvement, a modest improvement. But we can also see that this improvement is only achievable when using both the additional features and the additional training data. So the paper also contains some per class performance comparison between the baseline and the final approach. So to wrap up, we addressed in this paper the classification of NSUs, which is an important in dialogue, an important problem, but somewhat understudied, mostly because of the scarcity of labeled labeled data. So, but even though it's somewhat understudied, we proved that the performances can be improved, so it's not a no plus task. And for future work, we plan to use more deep semantic features to exploit more deeper semantic patterns, and to try to have more reliable data for testing. And this work was also, if you're interested, the work was part of also bigger work with that addressed also NSU resolution, which is the task of extracting the meaning of the NSU using this classification. So thank you very much. Yes.
Yes. Question now.
Yeah. I wonder if you have a necessity of defining any dominion, because in principle NSU are infinite classes problem, because it comes from the spoken speech, so
yes.
spoken language. So the problem is that the classify you this one. Okay.
Okay.
So this kind of classification strictly comes from pragmatic studies.
Okay.
So if you want to disambiguate and give also semantics of these structures, you need to go to theory of speech acts in general. So
yeah, but it's really tailored to this kind of utterances. So while speech acts covers much broader kind of utterances, those utterances are on.
So you have a special dominion for your task.
Yeah, the NSUs that are those ones that do not have a complete form. You see, they are quite responsive. They're very specific utterances.
My very fast second question is: if you start from BNC, you probably have also the audio files.
Come again, sorry.
If you come from the BNC corpus, you
Yes.
probably also have the audio files of this.
Yeah, but we didn't use it because
Give them to me,
the previous work.
Okay, any other question? I have one very quick question. You told us that you use as a context only the preceding utterance.
Yes, because it usually suffices to.
It usually suffices, but did you find any case that because in principle we can conceive that cases in which
as in these examples, for example, the utterance were not. I mean, the antecedent, as defined by Fernandez et al., was not exactly the previous utterance, but it can be also some utterance in the dialogue history.
Okay.
So, as in this example, it can be resolved by the second last utterance.
Exactly.
Yeah, of course, you can have some utterance that has to be resolved with more than the one utterance before. But I mean, they're not really frequent. And,
okay, let's thank the speaker again.
Thank you.
Thank you. The next speaker is José de Souza, and he will talk about the reference-free and confidence-independent binary quality estimation for automatic speech recognition.
Okay. Hi, my name is José. I'm going to present a work that was led by Hamed Zamani, which was an internship student here in FBK in the HLT unit. Unfortunately, he cannot be here to present. And this is, of course, a joint work by him, me, Matteo Negri, Marco Turchi, and Daniele Falavina. The idea is to present a system that can predict the quality of automatically transcribed speech without resorting to references. So I can have predictions at real time. So to give an idea about what this is, we have like a signal that is going to passed by an ASR system, and this system is going to generate a transcription for that. Then the quality estimation is going to use only the signal and this transcription, and is going to emit, is going to give a score, a label for that. In this case, we are focusing on binary decisions, binary predictions, to remove from, so previous work was trying to predict the word error rate. And in this case, we are trying to remove the burden from the user to threshold it at bad or good. So we already give a binary decision to that. So we don't use reference at deployment time. We don't necessarily need to access the ASR system. Therefore, we can decide to either use or not the confidence information coming from the ASR system. And of course, in order to make this work, we need somehow to have to generalize from some data, and we do that by using a supervised learning approach. Some applications for quality estimation of ASR could be evaluate dialogue systems transcriptions on the fly. So you are interacting with the system, and the system is able to understand what you're saying, and also emit different answers, and it could have an evaluation about what is understanding and predicting on the fly. It can be used also to decide if an automatically generated transcriptions requires manual revision after transcription, so you can decide if the quality is good enough for publishing. It could also be used in a situation in which one needs to select training data out of a big pool of out-of-domain data for acoustic modeling, and for that it could be used active learning approach like the previous work. Thanks for that, you already explained. Using QE as an informed function for deciding whether to keep or not a given example in for selecting the training data. So a bit more about how this approach goes. Basically, you have a training phase and a test phase, an evaluation phase in which the system is deployed. So this is the first sketch that I showed you before. So you have the transcription, the signal passing through the system, and finally the transcription. Then you have a step that extract information about this transcription and the signal. And if one needs or wants or also have access, it can also access the ASR system. Just to make the difference here between, there are some contexts in which you don't have access to that, to the system, the underlying system that generated the transcriptions. So for example, I want to give a quality prediction for captions in YouTube. I don't have the ASR system that Google uses to generate. I could use this, the Google system as a black box, and just look at the signal, the audio signal and the transcription. So after feature extraction, this is given to a training supervised learning algorithm. And of course, in this case, we need labels, and the labels are computed by looking at both the transcription and the reference at the same time. We compute the notion of quality that we want to give, and I'm going to talk about this a bit later. And with the features, with the information about the two components, the signal and the transcription, plus the label, I can have a supervised system. With this model, we are able to deploy the system in real time, and basically the first part of the pipeline is repeated. We use the quality estimation model to predict the quality, to give quality decisions about utterances. So about the features, we have for this work I'm presenting, we experimented with 68 features that were proposed previously in the literature. Let's say group of features focus only on signal, and the idea here is to capture the difficulty of transcribing the signal. And things like the total segment duration, max raw energy, and so on and so forth are captured. The second is looking only at the transcription, so only at the text. And we capture the plausibility of the generated transcription. And here, one very easy feature to compute is the language model log probability for that transcription. Then we have something that is what we are calling hybrid features, which is more fine-grained information that take into consideration word time boundaries and therefore connect somehow the signal to the transcription. One example is the number of silence. And then just to make a difference between black box and glass box, we can also take, so all these three features that we mentioned are black box in the sense that they are system agnostic. And we can have glass box features that are actually picking the system if you have access to them. And the label is the word error rate between the transcription and its reference. And it's basically the minimum number of edits required to transform the transcription into the reference. So we have two approaches here. I'm going to go over them fast because. So basically we do a binary decision doing classification via regression, in which first we train the regression models using the 0 to 1 word error rate labels. Then we threshold this at a given threshold depending on the application that we want. And based on this thresholding, we are able to give a decision about quality. A second is using standard classification in which the training labels, the WR range, are binarized a priori, also according to a given threshold. We give to the training algorithm, a classification in this case, obtain a model, and then we obtain the quality decision. So as a baseline, we are using, for the experiments, we are using majority class. BA is balanced accuracy. I'm going to mention this a bit later. So this is let's say the lower bound. And we have two terms of comparison. One is an oracle that basically, given all these systems that I'm going to lay out next, selects the best prediction among multiple outputs. So it's it's an oracle because it's impossible to do this in real time. And then we have a full-fledged QE that is basically using glass box features confidence information. And then we have 4 different learning algorithms that we use. We have we have always classification and regression. So we have SVMs, extremely randomized trees, maximal entropy, and stacking. So all but maximal entropy and stacking is only for classification. The other two are for both regression and classification. The stacking is a combination of the regression and classification together in an ensemble, in an attempt to see if they somehow complement each other and get the best out of their output. So it's a voting mechanism. Basic experimental settings, we are using a WSLT evaluation campaign, the test sets from 2012 and 2013, roughly 2,200 tuples with signal transcription and references that we can use for train and test. We always have about 50% for training and for evaluation. Yeah, we generated the transcriptions with the FBK-SR system. And we have two kinds of evaluation conditions. One in which we train and test on 2012 and 2013, and another in which we train on 2012 and test on 2013. This means that when we are in the same year, we are doing random sampling over the same talks. And when we jump from train to test to another year, we have slightly different talks. And the evaluation metric is this balanced accuracy that I mentioned before, which is suitable for settings with high class imbalance, because when I set the threshold that I mentioned before, we end up with very little data for one class and much more for the other. So we are measuring this situation that gives give equal importance to both classes. So some results. When we threshold the data at the very beginning of the WR range, which means that we are focusing on on identifying good transcriptions, we have these results. Classification via regression outperforms our baseline, which is the majority, in almost all cases, except when we are using black box features only and in a kind of out-of-domain context, which is training on 2012 and evaluating on 2013. When you go for classification, standard classification, you have a jump, and it's statistically significant. And then when we use the stacking, we have another jump, because it uses the information of all the previous bars that you see to make a more robust model. And still, we don't reach the same accuracy of the Oracle, but the Oracle is an upper bound for us. Then we have the same similar result for when we have a different threshold, which is like focusing on the bad transcriptions. And here, the major difference is that the classification via regression is a lot better than before in comparison. And stacking still outperforms all the models. So as a conclusion, I presented here an approach for binary prediction of automatic transcription quality, which is reference-free. It can be confidence independent and can be optimized towards specific applications, depending on the requirement, if you need to focus on good transcriptions or bad transcriptions. The best system is ensembling different models that either approach it via regression or classification. And one nice thing is that with system-agnostic features, we reach reasonable performance that varies from 75 to 78 balanced accuracy. So that's what I have to tell you. Thanks a lot.
Are there any questions? No questions? I have a couple of questions. It sounds to me a bit strange, the splitting about training and test set, the 50-50 splitting. I understand the experiments between 2012 and 2013 to have a completely different set of utterances. But when you mixed all both years, it sounds strange to split 50-50 the performances.
Okay,
what's the explanation?
That was not clear. I'm sorry. The experimental setting is the following: we don't mix the training data. We always have the training data only 1 year, but we evaluate on the other year.
Always.
Always.
Okay. I see. That's the reason for 50-50 splitting. Yeah. So you didn't try to mix the year and have a more standard splitting?
Yeah, that's a good idea, but we wanted to evaluate how this kind of approach, how does it deal with some sort of domain drift? Even though they are TED Talks, I mean, somehow they are the same, like, generic domain. TED Talks can be very different in different topics inside, so intra-topic. And as we know that there are no complete intersection between 2012 and 2013, this would be a nice thing to evaluate.
Very quick last question about the features. Could you please tell us more about the feature, especially the signal features that you use?
Yeah, okay.
A bit more.
I am not a speech guy. What I know is that it is basically analyzing frequencies and doing signal processing over that. Then I can refer you to a paper where we first use these features, and there is the full description of them.
Okay.
And I don't know if Daniele wanted to add something.
Which are averaged across segment to classify.
So standard features, nothing special.
Yes, more or less standard features, and we also included pitch features, which are more complex to compute because we didn't focus on computational efficiency for this work.
Okay.
And they were based also on previous work. I mean, in the sense we didn't invent anything new in terms of
signal features.
Signal features.
Yeah. Okay. Let's thank the speaker again.
Thank you.
and move to the next speaker. So, the next speaker is Maria Simi, that will present the evolution of Italian Treebank and dependency parsing toward universal dependencies.
Okay, this work is about the recent developments in the evolution of the Italian Treebank, and it's a joint work which I did with an undergraduate student, Simone Saletti and Giuseppe Attardi, because we want also to measure the performance of the parser on the new versions of the Italian resources. So I will talk about the evolution of the Italian Treebanks for those of you who do not know. And this is a joint work that I've been doing with other people from the University of Turin and from Pisa, in particular Cristina Bosco and Simonetta Montemagni. And then I will talk about the experiments that the student did about measuring the performance of the parser. And in particular, we wanted to measure the performance of single parsers rather than parser combinations, and to measure also the accuracy and the speed of the parsers. So to quote Simonetta, building a Treebank is like building a cathedral. It requires the work of many people for many years. This is a slide that she presented last year at the REC. And so I want to tell you about a short story, about a long story in this slide. So it all started in around the year 2000, and there were two different Treebanks that started to appear in that period, the Italian syntactic semantic Treebank and the Turing Universal Treebank. And they were developed independently along the years, and TUT was the basis for many Evalita competitions for the parsing task. And the ESST call was derived from ESST, and we participated with in the call 2007, and then was further developed in a project which was called SemaWiki, and then used also in the SPLAT task on domain adaptation on legal text. And thanks to the project Pre-Imparli, we decided to merge the two resources, so to get a large resource for Italian. And we used, this was called the MID, Merged Italian Dependency Treebank. It was around 2012. And so the effort was to harmonize, make a fusion of these two resources using this bridge notation. And thanks to that, we were able to produce an Italian version of the Stanford dependencies, and this was the basis for the Evalita task last year, the parsing task. And we added more data along the way, and then we were in the position in January to join the Universal Dependencies effort. As you know, as you maybe know, Universal Dependencies is an effort carried out by an international consortium to develop an international cross-language annotation guidelines to foster cross-language parsing experiments and multilingual research, linguistic research. And so we already released 3 versions of this Treebank in January, May, and recently in November. Along the way, we added more data, the parallel TUT converted. And so this was, we have now a large resource, large enough resource, above 300,000 tokens, which we didn't have it before. And we hope to have more data, and we welcome contribution from other people to this effort. Okay, for the purpose of this paper, okay, I will focus on a comparison between the resources that we released for Evalita last year and the second version of the Universal Treebank. So we want to measure the difference in parsing among these two resources. And so in the first experiment, we do take a subset of the UD, ET version 1.1, and corresponding to the same data as Evalita. And so we make this comparison. And then we measure the impact of adding more data. And we do this comparing the performance of the parsers. What has been changing in moving from ESDT to UD? The principle that content words are ahead of their sentence becomes prescriptive. So, and these, you can see two instances of that. Copular verb becomes dependent on the predicate. In particular, in Italian, the verb essere becomes dependent of its predicate and connected with the copulation. And preposition becomes dependent on their object. So the object of the preposition is directly linked to the noun, and with the case marking. And then we have a splitting of articulated propositions, and we have a different format. It's not the traditional con LL tab format, but we have a format which is able to accommodate. Well, Beppe says to say that we did this with the contribution of Google. We had a donation from Google for doing this work. Okay. So we have a way. This is the con U format, which accommodates the possibility of fused words, like verb with clitics or articulated proposition, both in the final form and the split form. And this is an example that shows you how different the structure of the parse tree can be, like moving from ESDT to UD. Okay? Sorry. The predicate, the verb to be is not anymore the head of the sentences, but it becomes a dependent with the copulation, and the prepositional the preposition is not anymore the head of the prepositional complement, but becomes dependent with the case mark here and here, and you have the splitting of the articulated proposition. So the structure of the trees is much different, and so we wanted to measure how the parsers perform on this new structure. This is to say that copular invention is controversial. So in the case of prepositional complements, predicates, like in this case, we have strange results. So we are still discussing this. So if you join this effort, you will be able to join also the discussion. In this case, it doesn't seem appropriate to invert the copula, okay? So this is still under debate in the consortium. For dependency parser, I'm going very quick on this part. We use different parser belonging to different categories. Desire is a representative of the transition-based parsers, and then we use two well-known graph-based parser, turbo parser and mate parser. And we choose Desire because we could easily try different configurations. So this slide compares the Evalita official results. In the first line were obtained with the parser combination. But here you see the single parser, how they perform on the Evalita data, and how they perform instead on the UDET version 1.1. So you see that there are improvements, and this was strange. We didn't expect this improvement. And if you do a simple tree combination, you see that you can beat the best Evalita result. Unfortunately, adding more training data didn't improve. And I think the explanation for this was that the new data were not fully harmonized with the previous Treebank. And so we hope that is not a definite negative result. Okay, these are the data. If you experiment with the data in the official release, you get these results. The splitting between training and test was different, and the results on the development test and the test are those. So we observe an improvement with respect to the previous results. Okay, I skip this and go directly to the conclusion. So we see a positive trend in parsing technology. The parser performance improves as the Italian resources evolves. So we already are able to get better result than Evalita with the new resource. And graph-based parsers still achieve a better accuracy with respect to transition-based ones, but the difference in performance drops when we use, as we did in these experiments, third-order features. So there is a space for improvement. Transition-based parsers are still faster, and here you see the figures. So it really depends on what you want to do with the parser. So we recommend use a transition-based when speed is important, and for accuracy it's better to use a graph-based parser. Okay, this is all.
Thank you. One question there.
Thank you. This is very interesting. I'll try to use the Treebank. I have a question on the results. Did the baseline change in the different versions of the Treebank? You have an improvement on the new versions of a Treebank for all the parsers. So my first question is, did the baseline just become higher? And so, you know, everybody goes up.
I don't see the question.
What was the baseline for the different versions of the Treebank?
We took the Evalita results as the baseline, and we measure whether if changing the resource with the same parser improves the results. And the question is yes. The answer is yes.
Yes, but if you change a resource, the baseline can change, right? I think you're comparing to the, I don't know how it's to say.
Someone? Oh, We did run the parser on the new resources, right? Oh, these are parsers done by others. So I think they are the best parser available now. So yeah.
I think that
now we took the same data in the first experiment, annotated in different in a different way, and the resource was better. The second resource was better. Adding more data didn't prove much.
I think that we have to stop the discussion. We have to move to the next speaker. Sorry, but the organizer pressing. So the next speaker is Giuseppe Attardi, and he will speak about detecting the scope of negations in clinical notes.
Okay, so we've been working on studying clinical records in the past years, and this is a significant area of activity. For example, few countries in Europe are requiring that from the clinical records be annotated with the mentions and the official codes from ICD-9 or ICD-10. And right now, all the hospitals are doing this by hand, or providing or paying people to do this by hand. So there's no automation there. So the problem is that you don't have just to find the dimensions of diseases or body parts or medicines that are mentioned in the clinical records, but you also have to distinguish when the mention is positive or negative. For example, if in physical records, after a visit, the physician tells everything he noticed, what he found and what he didn't found. So medical records are full of these annotation, negative or speculative. For example, no signs of liver disease, or absence of thrombosis, or it could lead to heart failure, something that is not definitely present. This is something that is very frequent there. Something like 15% of the sentences have these occurrences of negation or speculation, and it's not so frequent in other cases. For instance, in news there's very, very rarely negative information. A little bit in movie reviews is not his best movie, but it's marginal. In this case, it's very frequent. And it's very important, because if you make a mistake, then all processing that you do afterwards will be skewed. Like how many people have thrombosis? If you just ask the search engine, it will return that, because the word thrombosis is present. But it's negative context, we should distinguish it. So the approaches to this have been in the past rule-based systems and machine learning systems. Machine learning systems typically use a classifier which tries to decide whether a word is part of a context of a Q word, which is not negative, absence, and so on. And so they have the problem that these are independent decisions. So you might have something which is not a continuous sequence, because you just maybe skip one word because the classifier makes a mistake, and so you don't get the full sentence. So our approach is to use this two-step process. The first one is to detect the cues, so the words which carry negative or speculative meaning. And in this example, it says, consistent with the regulations, no charge in protein level was observed. So in this case, the negative cue is the word no. And the negative scope is the one that you see in red. It's no charge in protein level was observed. So we do this in two steps. First is to detect the cue, and then to figure out to what words it applies. So for cue detection, we use a sequence tagger. Actually, this is a dependency, deep learning dependency parsing that you can find on our library DeepNL, so it's a little bit of punch, and it works by just typical name entity recognizers. So you have information annotated as with the IOB notation, as you can see on the left, The results indicate that expression of these genes could contribute to nuclear signal mechanism, and indicate that is one of the cues. And so it's annotated with the speculation, begin speculation and inside speculation on the right column. And we use features which are morphological features, attribute features like part of speech, and dictionary features, so we know certain words which have negative content, so on, that these are used by, fairly traditional sequence tagger, and we obtain, we see reasonable results there. The second step is the scope detection, so figure out the extent of the negation. And so we are assuming here that scopes are contiguous, which is actually true for the training set that we're using. It's the bioscope corpus. And that the scopes contain the cue, or the scope itself, the cue is part itself of the scope. And the parse tree is projected, which is also true in our case. The training set is in English, so it's all projected. So a quick sketch of the algorithm. What you do, we parse a sentence. We found the cue. We start from the cue that was identified in the previous stage, and then we try to extend it, either to the left or to the right, as far as we can. Just here how it works. So we start with the word no, which is the cue, and then we can try to move either to the left or to the right. The first thing we do is identify what we call the left adjacent list, which are nodes which are on the same level, so siblings to the left of the word or the cue that we are considering. In this case, it's consistent, and the comma, which you don't see because it's in the between there. And so then we try to find whether we can take one of those and add them to the context to extend it to the right. So in this case, you can imagine that we will decide that no and the comma are not together, and so we stop going to the left, but instead we'll be going to the right here by the similar process. So we define the right adjacency lists, and then we try to check all of them. Notice that the right adjacency list doesn't contain the whole substring, just contains the top level of the tree. And we go through this by using a decision procedure, which goes navigating through the tree. So we take, let's see, takes a node, for example, in the node, and tries to find whether the adjacent word in the right adjacent list has to be or can be considered a part of that scope, extending it to the right. We do this using a classifier that takes some feature from the tree again. So, for instance, if you're extending to the left and you have the word, the candidate C that wants to be extended to the left, and it's part of a parent P, you might want to add it CS, which is a sibling to the left of C. But in order to do that, you have also to ensure that everything that comes to the right of CS is also part of the queue. So the decision procedure must be the classifier. For the classifier, must take into account all of the four nodes, which are C, the parent, the sibling, and the top rightmost descendant, which is the closest one to C, which possibly it's representing the boundary there. So this is an example of, and we take these four nodes and we extract feature for those, and we pass it to a classifier, which will decide whether this is the case for extending to the left. Another case is the picture, the subtree on the right, where you have to, there are no other siblings to the left, you have to go to the parent and then go back to the left. Okay, so this is just observation, the scope might not be a full subtree. So for, in this example, the failure, this is not part of the scope. This is how it was annotated in bioscope, so we have to deal with that too. So the algorithm can be proved correct, so it always terminates with a contiguous sequence of tokens which include the clue. And so we did this experimented on the bioscope corpus, which is a corpus of biological or medical literature, which is annotated with the negation and speculation. And we converted it to our fairly standard IUB notation with an extra column to represent the scope. Since one sentence or phrase can participate in more than one scope, the column on the right lists all the scopes in which an element is part. So the results are these. So for Q detections, we tested 3 different name entity taggers. So, classifiers. So the lib linear, which is a SVM linear SVM based. Then the tunnel, which is our name entity recognizer, which achieved the best precision and the best F1, over 90%. And DeepNL, which is the one that I was mentioning, which is using the deep neural network for training and testing. So, and these are reasonably good results in Q detection. The scope detection, we have tested there was a task at Connell 2010 about speculation detection on this corpus. So we can compare our result with those in that competition just for speculation. So the result on the bottom show the top scoring system at that competition, which was you see the score are fairly low with respect to our typical studies, because here the computation is done, the accuracy is considered about with the percentage of correct score, which means not only individual tokens are correct, but the whole subsequence is the whole context is correctly, completely identified. So that's why the scores are much lower than you see normal in other competition, our test. So nevertheless, our system beats the best score, the best system there in speculation, which is a reasonably hard task to handle. And in negation, we don't have comparison, and you see that we did our own split of the train and source of the corpus, train development and test, and there we achieve something which is a score around 78% and F1, and again the percentage correct score is quite lower as you can imagine. So conclusions. We presented a 2-step approach to speculation and negation detection. We exploited the parse tree of sentences, and the parse tree is used as a guide to decide how to move, which are the element and token to be used to extend. And we achieve better than the state-of-the-art accuracy, in particular because we avoid these spurious scopes which are discontiguous, and we have a resilience and flexibility because you can deal with situations where not all the subtree of the parse tree is part of the final scope. Okay, thank you.
Thanks to the speaker. Any question?
When you compare with the liblinear, are these results with the simple linear kernel, or
Yes.
did you employ some
this is
polynomial one?
SVN linear with a linear SVM.
Okay.
With an SVM.
You said there's no comparison in Italian. You mean for
no, these are English.
detection? These
No,
are
no.
English.
Yeah, the base corpus is
one
English.
paper I have in front of me is by Google Group, and they achieve lower than your PCS, 52.2 and 45.7. It's on the web. It's an
On
ECL
negation
paper.
detection.
PCS, yeah,
Okay, thank you.
yeah, it's much better.
It's lower,
Yeah.
so
It's
Yeah.
lower.
bravo. No problem at all.
Yes.
So any other question?
Okay, the examples you showed in English were the no as a subject, if I don't remember. So it was a passive, right?
Huh?
So
No, the subject.
Exactly.
No, it's a modifier. No, it's a
no change.
Yeah,
No
so-
change in protein level was observed.
Yes.
Now, if the no changes the object, so the exams revealed the no change in whatever. In this case, it's you take it as a
object.
scope, also the verb, or no?
It's decided by the people that did the annotation on the scope.
Okay.
And it's not. We didn't.
So
do
you
the
just you
annotation.
didn't.
No, we just took the bioscope annotation as provided by the competition, and
Okay.
so I'm not sure. I mean, we can check what happens. I mean,
Okay. Thanks.
Not,
Okay, very last question from Bernardo.
Following up Alessandro's remark, so is there any consensus of what is the scope of a negation in general? I mean,
don't ask me. Don't ask me. I'm not a linguist.
There is.
Yeah, I mean, I understand the question, but I mean, I'm not
I think that we
the
have,
right person to answer it.
Okay.
we have to leave this question as open. Let's thank the speaker again and close the session.
Let's.
Okay.
Allora, la prima sarebbe Nicole. Tu sai invece.
No, io non so.
Okay, let's start with the next session, which is intended in preparation of Evalita 2016. Nicole, I will invite Nicole to start.
Shall we use? Okay.
We'll start the time.
Okay, I will try to be. Good morning, everybody. I'm Nicole Novielli from the University of Bari, and this is a joint work with Paolo Basile, Valerio Basile, and Malvina Nissim. So I will try to be very quick because what we want to do is try to foster discussion about possible open challenges that it's worth to address in the next edition of Evalita. So it's just a collection of thoughts, a reflection, and open issue that could be of interest for the next track, for the next Evalita. So as we've already seen, also looking at the presentation yesterday and also in the poster session, there is an increasing interest on analyzing microblogs. So tweets in particular, but more in general, social media are raising a lot of attention among researchers because of the huge amount of data available, and also because of the wide range of possible application for analysis of socio-economic phenomena, commercial purposes, and so on. So on one side, we have this increasing trend of interest towards sentiment analysis in Twitter, as also attested by the success of the SemEval series. And in the 2014, Evalita also opened successfully a track on sentiment analysis by promoting a task on sentiment and polarity classification, which is a Sentipol task with 3 subtasks about subjectivity and polarity classification, which was the most popular, and the irony detection, which is actually the most challenging, also in terms of annotation. And the majority of systems were machine learning and supervised system, including the one who scored or ranked first. And we have only 2 rules-based systems, which different from the other. This is a trend that we can also observe in the SemEval series, actually. And we have 11 teams submitting 35 rounds overall, and also some interest from teams coming from the industry. So on the other side, we have this increasing interest on named entity recognition and linking in tweets, which is again increasing also in terms of also as a task for evaluation campaigns. So what we were trying to do with this contribution is to foster discussion about the possibility to merge these 2 aspects and to organize some new tasks, some new challenges on the on shared data, because merging the both named entity recognition and entity-based sentiment analysis could be of great interest for a wide range of applications, as we've already already seen, for example, for political debates on La Buona Scuola, and all the talks we have seen yesterday, also for name identity linking, sentiment analysis on Twitter. So there's a huge potential in exploiting these two research issue in combination. So what we are proposing is to organize different tasks, or maybe also separate tracks, as Semi-Valley is now doing, for example, for the sentiment, which has several tasks regarding the sentiment analysis. And what we are trying to suggest is let's discuss about the possibility of have this task organized around shared data. So we can also allow people to select which task they would like to participate in, or maybe develop system, end-to-end system as a pipeline, on possible pipeline on the same data. So on one side, we have this problem of detecting the sentiment attached to a specific entity. Yesterday, we were talking also about stance detection, and again, it might sound a repetition, but this is basically one of the hot topic discussing we're discussing in this day. So it's highly relevant for mining political sentiment towards a topic, towards an entity. Also, it has some potential for commercial application, for health issue, for recovery strategies after a disaster. We have seen also a lot of study on the Twitter about the Arab Springs and so on. So it's a huge potential attached to this research topic. So, and of course, for the annotation of entities, as we were saying in the presentation by Annalina Caputo yesterday, we should complying with the standard used in the previous task of entity linking, because we need to identify both the, where the entity is located in the tweet, and also the resource identifier in a knowledge base. So, a second issue we would like to discuss is the problem of having mainly, this is a trend which has been observed also in the English language competition. So there is a prevalence of supervised machine learning based system, because of course this guarantee the best performance in terms of the challenge. So it's easily to train a highly performing system. But what can be observed when testing the system on a different data set, on after, let's say, 6 months on new data collected about the same topic, we can see that while being in principle agnostic with respect to this issue, actually supervised system based on machine learning sometimes show to have some limitation with respect to the dependence on a domain, and also have low temporal validity. You can imagine the sentiment attached to the word France or Paris, how it is shifting toward negative, which was something probably unexpected or unobserved just 2 months ago, probably. Or names of country afflicted by war are usually learned as a predictive of negative sentiment, but not because they have an a priori negative polarity, just because of the concept of usage. Or, for example, in technological review, you can have killer features such as, I don't know, the memory or the processor or whatever, which can be predictive of positive judgment of users, of a customer, but which can become very quickly obsolete. So they're not predictive anymore, and you need to collect new data and retrain the system. So this is a problem, because we have this shift toward, machine learning supervised system, but we have to be sure that the system we are training and we are developing are robust enough to be cross-domain and to have a better temporal validity. And also, this is an example of the Sentipol data. We have seen that some hashtags, such as Grillo and Monti, mainly appear in negative tweets, which is highly dependent on the context and also on the time window used referred to for the collection of data. And also we have observed another phenomenon which is common to the La Buona Scuola dataset, where we have a higher percentage of negative tweets, because probably people use the social media mainly to complain. So we don't want to induce this bias also in our classifier. So we have to reason how to try to induce people to explore new approaches which try to overcome this limitation. And finally, we have to deal also with the problem of figurative language, with the issue of figurative language, because recent studies highlighted that more than 20% of tweets shows some form of linguistic devices for figurative language. So in the previous edition of the sentiment analysis task in Temporal, there was this annotation of irony, and the irony detection task was also included in the competition. So this is something we want to deal with, because while irony seems to mainly act as a polarity reverser, other linguistic devices for figurative language might act differently. So it's something that we need to take into consideration. So to complete, we need to adapt the annotation schema also to represent this phenomenon. As for example, we want to attach a label to the tweet for both the literal polarity, as in this case, and the overall polarity, as for example, resulting from the presence of irony, which acts as a reverser. So as a resources, we have full possibility. We have plenty of possibility. We have the Temporal dataset, which can be extended using also the political topic flag, which was included in the annotation. So a possibility could be to have two different datasets: a train set about a topic, about a domain, let's say a political topic, and a test set regarding a completely different domain, also exploiting hashtag, so as to foster people to try to reason more about why including such feature, and trying to limitate the bias due to the domain dependence of machine learning approaches. So, and also we have the Twitter dataset, of course, which I've seen, and the Italian dataset of manually labeled named entity, which were discussed yesterday. So to conclude and to recap quickly, we believe that both entity linking and sentiment analysis are timely and attractive tasks for the NLP community. And we also believe that a huge potential could be exploited by merging the two techniques on task on shared data. So we have several options. We can run different tasks. We can open a track with subtask. I just would like to simulate discussion since we have the panel. So I think it's good to have this few points in mind. So we have to reason on how annotation is affected with the with respect to the goal of the annotation. So and also to prevent the challenge-bound system, which is a phenomenon which is not very is mainly a problem we have observed in the English language competition. We could, for example, promote multiple rounds of mission by the same team. So one cannot take only one can take into account innovative approach that could be interesting from a point of view, from a research point of view, in the terms of advancement of knowledge in the computational linguistic field, but maybe probably do not assure the best performance. So that could be an option. And also we were discussing about the possibility of having a train and test set from different domains to try to stimulate novel approach in this sense. So that's basically it. I hope I'm being okay. Thank you.
Thanks, Nicole. I like it very much with this proposal because really you address the challenge to propose a meaningful merging between different tasks. And if you have any question, or if you prefer, we can go to the next presentation and then we can discuss all together in the panel. Maybe it's better if you agree. Okay, next presentation. FacTA, evaluation of event factuality and temporal anchoring from
Anne-Lyse
Minard. Anne-Lyse Minard.
Okay, good morning. So I will present a joint work that with Manuela Speranza, Rachele Spugnoli, and Tommaso Caselli. So in view of the Evalita 2016, we propose a new task on evaluation of event factuality and temporal anchoring. So I will start it with an example. So here it's an extract of news on May 2008. So where we see General Motors announced on Wednesday that its bondholders did not exchange General Motors debt for a 10% share in the company stock. And what we are interested in the events that are described in this piece of news. And we want to know if this event really happened and when did they happen and when they will happen. So first of all, so we can see in this example that we have two events. So General Motors announced, and we have the second one, and they did not exchange. Bond holders did not exchange. So we have these two an event in the definition of time email event, I would say. So it's something that a situation that happened, let's say, to be short, or that occur. And we have also in this piece of news two time expressions. So we have the date of creation of the document, first 28th of May, and another time expression, Wednesday. And so we want to, our proposed task is to focus on the factuality status of the event. So we want to know that if announced really happen or not. So in this case, it's a factual event, it's really occur, and exchange did not occur. So the bonders did not exchange the debt. And the second aspect of event in which we are interested is the temporal anchoring. So when did this event happen? So here we know that announced occurred on Wednesday. And we can see that exchange, as it is a counterfactual event, so something that did not happen, we cannot anchor it in time. So it's two aspects that are really related. So if we don't know the factuality status of an event, it's difficult to know if we can anchor it or not in time. So the task that we propose is composed by two subtasks. The factuality profiling and temporal anchoring, two really correlated tasks. And so just some technical aspect of the task. So we decided to give to the participants the gold event mention. So we proposed to give to the participants this gold event to focus only on the factuality and the temporal anchoring. The event detection has been already let's say there were already a task last year at Evalita in the eventee task on event detection. There are already data, and so we want to focus more on these two aspects and not on event detection. And the second thing is that we want to evaluate independently these two tasks to evaluate the two phenomena, and also to allow people who want only to participate to one of the subtasks to do it. So now I will describe the two subtasks a bit more in detail. So first, what is event factuality? So in literature, Sori and Pustejowski propose a definition of event factuality that is a level of committed belief expressed by relevant source towards the factual status of events mentioned in text. So from this definition and from the work of Vasson and Chantal Vasson and also the newsreader guidelines, we defined factuality through three attributes: the certainty, the polarity, and the time. So the certainty is how sure the source is about the mentioned event. So it can be certain, probable, possible, or underspecified. The polarity, so does the event affirmed or negated, so positive, negative, or underspecified in the case where it's not possible with the text to know it. And time, so when an event is reported to have taken place or to be going to take place. So for this one, we have three values: non-future, so is a past or present event, or future event, or underspecified. This is a really rare case. And we have these three attributes to describe the factuality status of an event. And we have also a special, let's say, tag that is no factuality annotation. So we have events that do not correlate with the real situation in the world. So in this case, we just say, okay, we cannot annotate factuality for this event. So quickly some examples. So the first example, l'aumento potrebbe riportare nelle case fino a 500.000 di euro. Portare is a possible positive future event. So potrebbe indicates that it's a possible event. So it's non-factual event. Then we have non annominato un amministratore. So this one is a counterfactual. So it's certain. The source is certain that the nomination, the appointment has not been done, and it's a negative event. And then finally, no factuality annotation example. So penso che sia prematuro parlare del nuovo preside. Parlare doesn't correlate with the real situation in the world, so we cannot annotate the factuality status. The second subtask, so temporal anchoring. So we started with the definition of narrative container, that is a temporal expression or an event explicitly mentioned in the text into which other events temporally fall. And we go in the direction of this definition, making it a bit simpler. So we define temporal anchoring as a task to associate all temporally grounded events to time anchors. Okay. And so this is defined by the, so we have the time expression in the text. So participants has to normalize, to define and to normalize the time, and to find the temporal relations that are of type is included or simultaneous. So just a quick example, l'appuntamento che in giugno era stato fissato per questa sera è stato rimando a giovedì. We have appuntamento that is included in giovedì with a normalized value of the time expression. We have rimandato that is included in the time expression as a document creation time, sorry, and fissato that is included giugno, so something that happened in June. So for the evaluation, we plan to use the precision recall and F1 score matrix. And okay, for factuality profiling, we have different kind of evaluations. The most important one is the assignation of the overall factuality value. And for temporal anchoring, we will evaluate the strict match of the relation. For the data, so we have one corpus for the training for factuality profiling, Treebank. For the evaluation, we will use a new corpus called Newsreader Wikinews Italian corpus that will be presented at the poster session this afternoon. And for temporal anchoring, we have the Eventi corpus of last year at Evalita last year, and the new Wikinews corpus. So yeah, just okay, yeah, it's the first task for factuality profiling for Italians that we propose, and it's also the first task that put together these two aspects. And so, yeah, it will be the occasion also to make available reference corpus for Italian. Thank you for your attention.
Thank you. Thank you again for this example of meaningful merging of tasks. And let's go with the last presentation of the session. Parsing events, a new perspective on all challenges. And I think the speaker is Tommaso Caselli. Okay.
Okay, yeah. I'm Tommaso, and I'm going to present this joint work with Raffaele Spagnoli, Felice Del Dorletta, Simonetta Montemagni, and Cristina Bosco. And these are some motivation that has led us to think about why doing proposing a new task. Or, well, we start looking at, there's this kind of observation that you can see looking at the semi-eval task right now. So evaluation exercises are getting really more and more complex. And what has happening, if you look at the different tasks, is that from the analysis of grammatical structure, we are moving more and more from the analysis of sentence semantics. And then from the analysis of a single document, we're moving to the analysis of multi-document. And also, what happened is that basic tasks, we're moving from basic tasks to really composite and articulated tasks. One of them that I'm thinking about, because I had this experience, is the semi-eval task from 2015 on cross-document timeline reconstruction, where the best system achieved an F1 of 8 point something. And just to let you think about how hard was that task. And again, the access, however, the other big observation is that access to the text content does not reach a fully satisfactory level yet, unfortunately. There are really more and more evidence that we need a kind of simultaneous access to grammar and semantics in order to understand the content of a document. And also, the other aspect that comes out from the state-of-the-art analysis that we did during the paper is that really the interaction between syntax and semantics has been widely explored, but really sometimes it's not really well understood what are the connections between these interfaces, these two aspects. And also there is a big variation cross-linguistically between these two really core elements. So on the basis of the conclusions that were proposed in the Evalita 2014 text evaluation paper, which has been presented in the Journal of Artificial Intelligence. So the organizers of the dependency parsing task and the organizers of the eventy task basically decided to think about going together. What happened is that dependency parsing and eventy task were two separate evaluation tasks that were proposed at Evalita, and they were separate in the sense that one of them was focused more on syntax and the other was focused more on semantics. And what happened is that there was really no bidirectional investigation of these two phenomena in a single text. So what we need is basically more complex evaluation exercises which try to tackle some really complex aspects. And what we are proposing is parsing events. So what we are proposing in the new evaluation task, we are aiming at investigating in a different way with respect to what has been done so far, basically the interaction between syntax and semantics. And what we propose is a real cross-fertilization task between these two aspects. We want to generate a new language resources which combine dependencies and dependency syntax and event information for Italian. And also we are aiming at developing kind of new evaluation methods for system, both as really complex information extraction architecture and as the single subcomponents that are involved in this stuff. Quickly and graphically, this is the idea that comes out of the parsing event. So from the dependency parsing task, basically we want to use the syntax information and all the syntax annotation in order to see if it could be possible to improve detection and, most importantly, classification of events. And from the eventy annotation and the eventy data set, we want to go back to syntax. And we want to see if having access to some kind of semantic information, so know if a token is an event and what type of event this token is, we can improve the identification of some parsing dependencies between the elements in a sentence. So what we are proposing is basically a single evaluation exercise, which is divided into 3 subtasks. So we will have a kind of main subtask where we want to evaluate jointly this connection between syntax and semantics. So we want to jointly identify dependency parsing and event detection and classification. And then we want to also to evaluate in 2 separate subtasks, the dependency parsing part and the event detection and classification. So the idea is that for the main task, participants will have access to goal data for training, including all the dependency relations, which are based on the ISDT annotation scheme, and also goal data annotations for the event detection and classifications, which were available on the based on the eventy scheme that has been developed for the eventy task at Evalita 2014. Including the event extent, if a token is an event or not, we will make available also all the attributes for the event. So we will make available what is the class to which this event belongs to, the temporal, the tense value, the aspect value. This corresponds to really superficial value of realization in case they're available. What is the mood, the verbal form, the V form is the verbal form, and the polarity. So basically if something is stated or negated. And for the subtask for dependency parsing, basically is going to be a standard dependency parsing task, but participants will have access to the gold event annotated data for the training part. And on the event detection part, we are going basically to propose again the type of evaluation for event detection and classification that was proposed on the eventy data set, eventy task. but participants will have dependency relation available for training. So overall, we are thinking that we can make available 3 different types of data sets. So there will be a goal data, manually annotating training data for parsing and deriving from the last edition of the Evalita 2014 parsing task and eventy task. Then we will make available silver data. So basically, it's automatically annotated data for dependency relations and events. And then we were going to create a new test set that we will call platinum data, where we manually annotate dependency relation and all the event information. The idea is that finally all this type of information is in a unified representation format, so that it is compliant with ConnellX format, just to make life easier for everybody. And the idea of the evaluation is that we're going to use measure based on precision and recall and F1 on the main task, and we want to see if it is possible to have correctness of the event and of the event class. That's important. It's not just the event mentioned, it's the event class and the dependency label. So this will be already a first part to check if there is any bidirectional influence between syntax and semantics on the basis of the information that we are going to provide. Then we will have the subtask A, which is dependency parsing, where we are basically making available the same standard evaluation measures for dependency parsing, so labeled attachment scores and non-labeled attachment scores. And then we have for the task B, again, we are going to use the precision recall and F1 for extent of the event, and we are going to use the temporal free measures for evaluating the event class, which is called the attribute F1, which has been elaborated by Usman and other people for the temporal free evaluation. The idea that we are having in mind is that for each subtask, we will explicitly ask the participants to provide their runs with and without the data from the other task. I'm concluding. Basically, the idea is that this explicit contrasting evaluation of the subtask is what we think is one of the major novelty in this proposal. This should lead to a better understanding of the impact and the role of the different types of information, and most importantly, we should be able to have a better error analysis, and if we are lucky, then using the error analysis to get better systems. And also, this should also provide some kind of new ideas, basically, or new research directions on what we call old challenges. I mean, these are kind of basic tasks. Okay, thank you.
Thank you very much for this last very interesting talk. And let's start with the panel. At the beginning, Raffaele will introduce some results of a survey we carried on in order to have feedback both from academic community and from industry about the future edition of Evalita, and then the panel that will be chaired by Franco.
Good morning. So I'll introduce the panel by providing you just a few of the many results we collected by using 2 online questionnaires we ran some months ago. The first questionnaire was designed for industrial companies working on Italian text and speech technologies in Italy and abroad. Our starting point for finding target enterprises were the White Book of TAL. The last edition was of 2009. Unfortunately, let's say, almost the 50% of the companies reported in that book are not more active today. So we used online repositories and also extensive web searches, and we created our own repository of 115 companies working on Italian. That is a quite large number. And almost the 50% of these companies are outside Italy. We contacted all these companies by email, and we had 39 responses. The majority are, of course, from Italy, and as you can see, the majority of these companies are in the central and north regions of Italy. But we had also some feedbacks from other countries.
The second questionnaire was for former participants and organizers of the last 2 editions of Evalita. We contacted by email 90 persons, and we had again 39 responses from PhD candidates, technologists, and researchers, most of all from university, but also from public and private research institutes. As you can see, the great majority, about 80% of companies expressed their interest in participating in Evalita in the future. But some weak points of the initiative emerged. First of all, Evalita is perceived as too academically oriented. There are two not application-oriented tasks. Then participating is very time-consuming and also a reputation risk in case of bad results. Another problem for companies is that the majority of, well, almost all the data sets that are used in training and test data cannot be used for commercial purposes after the end of Evalita. And another issue is that Evalita has only limited impact on media. In fact, indeed, this last issue emerged also from the fact that almost 30% of respondents were not aware about the existence of Evalita before starting the questionnaire. So with this questionnaire, we were lucky to get in touch with new people, and this makes clear that we have to work to enhance the visibility of the initiative. These are the most voted tasks of interest for companies. So sentiment analysis, named entity recognition, but also content analytics, word sense disambiguation, of course, parsing and something else. And for the other category, we have some interesting suggestions about new tasks, such as the dialogue analysis, social network analysis, and others. Moving on to the responses we had from participants and organizers, this chart shows you how the respondents rated their level of agreement toward the set of statements that were related to different aspects of Evalita, such as the organization of the final workshop and the evaluation, for example. The majority of feedbacks were positive for almost all the statements, and this is shown by the length of light blue and dark blue bars. In particular, we had a strong consensus about having a demo session during the workshop, and about trying to evaluate not only the system effectiveness, but also the replicability and also the usability of systems. Another important need for the community would be to have a shared and open platform on the web to share resources and systems that are available for Italian. More neutral or even negative feedback was given about having more roundtables and also about having business stands. And in this last slide, there is a comparison between industrial companies and former participants and organizers regarding the most interesting domains for future tasks. And it's worth noting that the most voted domains are the same, so social media, news, but also humanities, political administration had good feedbacks, most of all from companies. This should facilitate the creation of interesting tasks for both communities in the future. This was the last slide, so thank you for your attention. I give the floor to Franco. These are the discussion points of the panels.
Allora, d'accordo con gli organizzatori, il panel sarà in italiano, anche perché Evalita, insomma, suona, no? Sostanzialmente oggi si apre la nuova campagna Evalita. Le tappe fondamentali saranno la nomina del comitato scientifico da parte del consiglio direttivo dell'Associazione di Linguistica Computazionale, che avverrà ad Oras, immagino, e questo comitato farà partire le goal per le prossime, per i task. Da questo punto di vista, come sapete, il problema di Evalita è sempre, diciamo, grande entusiasmo iniziale e poi all'inizio ci sono un sacco di manifestazioni di interesse, poi i task sono difficili, le persone sono tutte molto impegnate, sullo speech non ne parliamo, poi abbiamo un capitolo a parte, e poi alla fine i numeri non sono mai esaltanti. Quindi l'idea è di inventarsi qualcosa per rendere Evalita più appealing, su questo punto, su questa base ci sono 3 domande fondamentali che noi facciamo ai nostri panelist. Abbiamo rappresentanti delle aziende, abbiamo rappresentanti dell'accademia, e le domande sono sostanzialmente i commenti sulle proposte che avete visto nella precedente sessione, come migliorare la visibilità di Evalita sia dal punto di vista dell'informazione dei social media che dal punto di vista dell'appealing scientifico e industriale, e quali sono le idee su come coinvolgere le aziende in Evalita, perché c'è anche il problema della misurabilità della qualità del lavoro delle aziende, che in qualche modo giustamente va salvaguardata nei limiti degli interessi economici che le aziende stesse mettono in campo. Io direi di non utilizzare l'ordine alfabetico, perché abbiamo 2 signore e dobbiamo essere cavalieri, e quindi io andrei dalla sinistra verso la destra e farei iniziare Maria Palmerini a rispondere a queste domande. Abbiamo pochissimo tempo perché siamo in ritardo, avevamo mezz'ora all'inizio e non so bene gli organizzatori che deadline mi danno, per cui vi prego di essere estremamente concisi. Quando devo chiudere?
Grazie.
10 minuti in tutto. Alle 13:10, ok.
Quindi quanti minuti ho? Rispetto
4.
ai 7? 4. Ah, ok, corriamo. Allora, buongiorno a tutti, io mi chiamo Maria Palmerini e sono qui per portare un po' la voce delle aziende, almeno di una, insomma, senza essere megalomani. Quindi vi racconto un attimo di che azienda faccio parte. Si chiama CEDAT 85, è un'azienda italiana che è nata come azienda che si occupa di fornitura di servizi, adesso mi impappino perché me l'ho preparata in inglese, servizi di resocontazione, verbalizzazione, trascrizione professionale. Da una decina d'anni, qualcosa meno, 7-8 anni, ha aperto un settore di ricerca e sviluppo che si occupa di speech, di tecnologie di trattamento automatico del parlato e di applicazioni principalmente basate sul riconoscimento vocale. È membro dell'AISB, è membro del Forum TAL e ha partecipato all'edizione di Evalita del 2009. Come è emerso anche dai risultati che presentava Rachele, ci sono alcuni aspetti critici per le aziende nel partecipare a campagne di valutazione come Evalita, ma direi a campagne di valutazione in generale, che sono essenzialmente, li ho raggruppati un po' in 2 punti, cioè un focus sulla valutazione delle tecnologie nude, anzi sulla tecnologia pura, insomma, piuttosto che sulle applicazioni, e l'approccio quantitativo, quindi proprio di competizione e misurazione in termini di accuratezza o di bontà o meno dei risultati, ma in termini numerici. Questo perché molte industrie investono le loro energie in ricerca e sviluppo principalmente sulle applicazioni, e non sono impegnate nella ricerca di base, essenzialmente perché molte non se lo possono permettere, poi c'è una questione molto pratica, e per questo motivo non sono interessate a esporre la loro tecnologia, a volte nemmeno a rivelare i propri componenti che stanno sotto le applicazioni, quindi ci sono anche poi problemi di informazione, di comunicazione di alcuni aspetti. Per quanto riguarda l'approccio quantitativo, ovviamente, mettendosi invece nei panni di una campagna di valutazione, i numeri sono importanti e hanno evidenti benefici, sono oggettivi, sono calcolati nello stesso modo per tutti i partecipanti, quindi sono comparabili, sono effettivamente l'unico criterio più facilmente comparabili. I numeri sono comunque utilizzati internamente anche nelle aziende per scopi di ricerca e sviluppo, e continuamente io lavoro nel settore di ricerca e sviluppo, continuamente ci interfacciamo con problemi di accuratezza misurata in termini numerici esattamente, e qualche volta, ma devo dire questo veramente sempre meno, sono anche richiesti dai clienti e nei bandi di gara, o proprio però veramente questo sempre meno, sempre più c'è attenzione mi conforta su questo anche l'intervento di stamattina di Google, che aveva grande attenzione proprio su questo, sul fatto che le applicazioni funzionino e sull'attesa proprio dei clienti. Quindi i numeri hanno questa doppia faccia, hanno un aspetto molto semplice da gestire, sembrano un'informazione molto chiara, ma a volte nascondono complessità, una complessità che sta dietro. Sto dicendo cose che sicuramente a questa platea di esperti risultano scontate, ma le aziende si devono continuamente invece relazionare con non esperti, e quindi devono purtroppo spiegare un sacco di cose. Avevo portato un esempio che non so se abbiamo il tempo di sentire, che è un piccolissimo segmento di audio.
Quanto dura?
10 secondi, credo,
Vai.
20 secondi. No, quella sotto è la trascrizione automatica, vedrete che ci sono alcuni errori. Ah, scusate.
Dalla situazione della finanza pubblica, confermare impegni di questo genere, e credo questo è l'orientamento emerso dalla maggioranza della Commissione, che abbia assolutamente senso.
Ok, era corto, sono stata veloce. Ci sono 2 punti di errori, no? Avete visto, uno è il primo, c'è un'inserzione, quel sì non è stato detto, adesso senza riascoltarlo. Nel secondo punto che ho evidenziato c'è una disfluenza, cioè l'oratore si impappina, si inceppa 2 volte, quindi dice le me, l'orientamento, ok? Allora, questo, di nuovo, dico una cosa scontata a tutti voi che siete tutti esperti, ma la domanda è: qual è la trascrizione attesa in questo punto? Cioè, qual è? Chiaramente c'è un errore, va bene, però rispetto a quale reference text mi devo mettere in relazione? Su questo discorso dell'analisi dell'errore noi abbiamo fatto una ricerca insieme all'Università di Salerno, che è stata presentata a questa stessa conferenza l'anno scorso, quindi abbiamo abbastanza lavorato anche proprio sull'analisi dell'errore. Allora, per dare il taglio che volevo, un po' problematico a questo intervento, senza dare risposte ma per sollevare interrogativi, quindi cosa avremmo dovuto scrivere nel reference text di quel segmento per misurare l'accuratezza di quel punto? E cosa significa quando io parlo di una certa percentuale di error rate, ripeto, verso non esperti? Gli sto dicendo che, ad esempio in quel segmento, ora il 10% è una cifra a caso, il sistema ha sbagliato il 10% o che il 10% di quello che è stato detto non è stato trascritto? Sì, ok, perfetto. E quindi, tornando di nuovo all'applicazione, per valutare la bontà di una trascrizione automatica, ad esempio nel nostro caso, non possiamo non chiederci a cosa serviva questa trascrizione, in che applicazione viene inserita. E quindi, per, diciamo così, dare un po' di input finali, gli interessi dell'industria sono, o almeno di alcune di quelle che simili alla nostra, spostare il focus dalla tecnologia pura alle applicazioni e stimolare la ricerca e lo sviluppo di soluzioni nuove, perché il mercato è abbastanza povero, soprattutto di soluzioni per la lingua italiana. La modalità che sarebbe più, diciamo, appetibile per un'azienda è meno pericolosa, forse anche, diciamo anche questo. È più la modalità in stile vetrina di applicazioni, con naturalmente anche una valutazione, ma una valutazione che si allontani dall'assegnazione di un punteggio proprio, ma che sia un po' più a tutto tondo sulla valutare, ad esempio, l'innovatività o la efficacia di un'applicazione, quindi dare una valutazione chiaramente più complessa da dare, ma più, diciamo, volta proprio ai casi d'uso, e che è un approccio più interessante per le aziende.
Grazie. Malvina. Tieni.
Meglio?
Sì.
No, visto che abbiamo il tempo contingentato, vado direttamente alle questioni. Allora, i contenuti. Allora, secondo me le 3 proposte che abbiamo visto adesso, ora lasciando anche quella in cui sono coinvolta io, che non mi sembra bello, ma bellissimo, mi sembrano tutte e 3 molto adatte e anche molto in tempo, soprattutto se, anche rispetto a quello che faceva vedere Rachele, la questione è legata anche all'internazionalizzazione di Evalita, cioè questo allineamento che sia nelle presentazioni sia oggettivamente esiste anche con Semeval mi sembra positivo, ecco. E anche si affianca all'interesse che è stato espresso sia da ricercatori sia da industria sui temi. La complessità che io vedo è la complessità dei task, però secondo me, e questo è un punto che mi andava molto di discutere e che ha menzionato anche Nicole, si può pensare a una struttura per track come esiste per Semeval, il che vuol dire che almeno within tracks si potrebbero utilizzare gli stessi dati, perché questa è un'altra questione, una cosa che volevo chiedere a Tommaso, ciao, è quando tu parli appunto dei 2 dati, dei 2 dataset, sono annotati, cioè eventi e parsing, sono gli stessi dati o no?
hanno dato 27.000 qualcosa token, quindi l'idea è come poi i due corporanno più di 100.000 token ognuno. L'idea è quella di dire ok, usiamo un secret data e poi ripeto, nessuno ha fatto il commitment di dire poi però li guardiamo tutti a mano. No, l'idea è quella di cercare di ridurre il costi di
Però creando nuovi dati, soprattutto se abbiamo delle track, secondo me questi dati, cioè vanno creati dei layer di annotazione sugli stessi dati, così che poi ognuno si fa l'intera pipeline se vuole, oppure se la prende da metà e va avanti, come anche sulla questione della fattualità. Voi date il gold degli eventi, però in realtà uno può voler annotare i suoi eventi da solo e vedere com'è end-to-end l'intera performance, no? Però questo ovviamente va fatto sugli stessi dati. Allora, secondo me, tracks, cioè, organizzazione in tracks, condividere i dati e l'altra cosa che, passando già alla logistica, però, è che secondo me ci vuole del supporto per questa cosa. Allora, una proposta, allora, la piattaforma se ne parlava già l'anno scorso con Sentipolk, perché c'erano state varie submission, ci sono i dati e tutto quanto, ci piaceva avere una piattaforma condivisa su cui mettere su tutti i sistemi e che poi ciascuno potesse provare, eccetera. Allora, questa cosa, perché limitarla ad uno dei task? Facciamola per vita. Però facciamola per valita, ci vuole ovviamente qualcuno che la faccia, che ovviamente non è banale. Non solo, lo sappiamo benissimo che uno dei bottleneck di queste campagne per organizzarle sono i dati annotati. Che se vogliamo continuare a spingere comunque, a parte per il test, però se vogliamo continuare almeno in parte anche a spingere verso sistemi supervisionati, un po' di training ci vorrà, quindi ci vogliono i dati annotati. Allora, una proposta che io avrei, visto che abbiamo la nuova associazione, è che per i task di Evalita che sono accettati, l'associazione dà un contributo agli organizzatori che possano pagare degli annotatori che sono studenti, o non lo so, in modo che questi dati poi vengano creati. Si può fare?
Si può fare anche un po' di crowdsourcing.
Ovviamente si può fare crowdsourcing, però che costa meno.
Sì, costa meno.
Però che costa meno, però costa pure quello, quindi da qualche parte questi soldi devono arrivare. Secondo me è una cosa bella e giusta che l'associazione possa dire un pochino per i task che sono accettati laddove servono i dati, potremmo contribuire con il coinvolgimento, ora a parte il crowdsourcing, però il coinvolgimento degli studenti secondo me sta anche dall'altro lato, però, perché una mia piccolissima esperienza che ho fatto nell'ultimo corso che ho insegnato a Groningen è che come progetto finale del corso, che era un corso di machine learning di base, li ho fatti partecipare a una shared task, cioè li ho preso, i dati mi servivano per farli provare, però siccome la shared task era attiva, gli ho detto, ho preso un gruppettino alla fine, ho detto ma facciamolo per davvero. E questi qua che era authorship verification dentro PAN. E questi qua alla fine sono 3 studenti di master che hanno messo su un sistema che è arrivato terzo su 18 in 3 settimane, un po' di più, vabbè, un po' di più. Però gli studenti ci sono, gli studenti a loro è piaciuto tantissimo, hanno voglia di lavorare e secondo me è un bel modo di coinvolgerli e a proposito di internazionalizzazione è un modo per far capire come funzionano le cose anche a livello internazionale. Quindi coinvolgere gli studenti a questo livello secondo me è fondamentale. Industrie, cioè visibilità, secondo me questo dà visibilità a a Evalita, a livello proprio di poi che visibilità vogliamo in più, cioè chi è che non lo sapeva? Non lo sapeva, no, la comunità
fuori
italiana
nomi,
lo sa.
fuori nomi.
No, ora, a parte tutto, la comunità italiana lo sa, cos'è che non facciamo? Beh, secondo me è visibile Evalita nella comunità italiana, magari nella comunità internazionale. No, lo so, però nell'industria non lo conosciamo. Posso però dire una cosa un po'... Posso però dire una cosa un po' provocatoria? Non me la dico una cosa provocatoria, vabbè. Come? Dilla. Per esempio, per generalizzare, secondo me questo è più un problema dell'industria che non dell'accademia. E possiamo accollarcene anche noi, perché a noi interessa ovviamente ed è un beneficio anche per noi collaborare con l'industria, ovviamente. Però secondo me noi non stiamo facendo poco, ecco. E anche nel modo in cui le campagne sono organizzate. Cioè a me sembra che noi non siamo in questo senso in difetto. Ora, cioè, mi dispiace se sembra presunzione e chiedo umilmente perdono alle aziende, però secondo me anche la collaborazione, per esempio, volendo, ho finito, please conclude, l'esperienza l'anno scorso che abbiamo avuto con Sentipol, c'era un membro aziendale tra gli organizzatori, ha funzionato perfettamente, però perché la collaborazione esiste, perché c'è informazione e tutto quanto, cioè non mi sembra sia stato, no? Cioè, volendo si può, ci siamo, sì, la condivisione dei dati, certo è un problema, perché però è chiaro che è research oriented in un certo senso, ma io personalmente, pur volendo molto il coinvolgimento delle aziende, non lo vedo un problema che ci dobbiamo accollare al 100% no.
Beppe.
E allora io farò delle considerazioni generali e poi delle considerazioni puntuali. Le considerazioni generali sono queste, che se questo è il task, le shared task sono un meccanismo di avanzamento della scienza. Quindi non facciamo confusione tra l'avanzamento della scienza e la pubblicità, oppure altri compiti come fare promozione aziendale, come abbiamo visto fare oggi in maniera del tutto inappropriata. Il fatto che questo ci sia un avanzamento scientifico richiede che i task abbiano una certa durata nel tempo, perché lo scopo del task è vedere come i sistemi evolvono nel corso degli anni. Quindi un task, una volta che deve andare avanti almeno 2 o 3 anni, perché sennò si perde completamente lo scopo. Cioè uno deve porlo un anno, il primo anno la gente fa i primi esperimenti, si familiarizza con il task, il secondo si vede se ci sono dei miglioramenti e così via. A un certo punto di solito quello che succede è che si arriva a un punto in cui si arriva al top e non c'è più miglioramento, a questo punto il task si abbandona perché tanto evidentemente si è già appreso abbastanza da quel task. Nel corso degli anni quello che può cambiare e possono cambiare le risorse, possono aumentare i dati a disposizione eccetera, ma il task deve essere stabile, deve essere sempre quello, perché il meccanismo dell'avanzamento scientifico attraverso queste campagne di valutazione consiste nel fare esperimenti, misurare i risultati, verificare la qualità del risultato rispetto all'esperimento precedente, se il risultato migliora vuol dire che siamo sulla strada giusta, se il risultato peggiora siamo sulla strada sbagliata, e quando siamo sulla strada sbagliata bisogna fare una correzione, riprovare, si riprova e il ciclo continua. E ora è stato citato malissimamente Google, perché ma Google fa esattamente così. Oggi il discorso era stato esattamente quello, che loro fanno in continuazione test e misure, addirittura cambiano in continuazione i dataset, perché una volta che il dataset è usato troppo diventa bruciato, va bene? Quindi la valutazione è sempre continua, è fondamentale e cruciale, non se ne può fare a meno in questo settore. E se non ci fosse stata le valutazioni di questa cosa, si parla di automatic speech recognition, non esisterebbe l'automatic speech recognition aziendale se non ci fosse stato il NIST a lanciare i task di open speech recognition negli anni 90, va bene? Pieraccini ce lo può ricordare, bene? Quindi non guardiamoci in fondo. Le shared task sono attività scientifiche condotte con tecniche e meccanismi scientifici che si basano su valutazioni numeriche. Le valutazioni numeriche non sono perfette, siamo tutti d'accordo che non sono perfette al 100%, però hanno una correlazione, c'è una correlazione stretta e verificabile tra le valutazioni fatte in maniera automatica, che non sono perfette, e le valutazioni fatte da giudici umani. C'è una correlazione, nel senso che ci sarà una piccola divergenza, eccetera, ma sono sostanzialmente in linea. Di solito, per esempio, sono esattamente corrette nel fare il ranking di sistemi. Cioè, se un sistema viene considerato migliore di un altro, state sicuri che sono davvero anche dagli umani giudicati uno migliore dell'altro. Questo è sicuro. Magari il valore, il numero di misura non sarà esatto al 100%, però lo score, diciamo, l'ordinamento, quello è quasi sicuramente vero. Quindi, detto questo, diciamo, per salvare, diciamo, questo aspetto scientifico che è fondamentale, se no possiamo andarcene via di qua perché non è più un'evalita. Passo invece agli argomenti più di dettaglio. Primo aspetto, come è stato già detto, sono troppo complicati questi task, tutti e tre. Mi spiace doverlo dire, ma è così. E siccome abbiamo detto che il problema è quello di far venire la gente a partecipare, già era difficile prima, se gli complichiamo il task non è che vengono di più, non è che cioè, rendendoli più difficili invogli la gente a venire. E abbiamo esattamente il problema opposto, cioè di convincere la gente a partecipare, visto che è uno sforzo impegnativo, eccetera, eccetera. Alla fine, poi, diciamo, il beneficio non è poi straordinario, non c'è visibilità nei media, eccetera, quindi come si fa? Bisogna, secondo me, sicuramente semplificare questi task, anche perché alcuni task, diciamo, in realtà alla fine sono task diversi, cioè sono semplicemente collage, e l'esperienza passata dimostra che i collage join task sono sempre stati un fallimento, perché join task ha sempre vinto, è stato primo il sistema che li faceva in cascata, quindi non c'è stata mai cross fertilization, sarebbe bello farlo, ma diciamo nella pratica, in realtà, non è mai successo. Quindi io semplificherei i task, poi farei molta attenzione a metterci dentro dei dati silver, perché a questo punto siamo rovinati, e se mettiamo i dati silver perdiamo completamente la validità scientifica, cioè l'obiettivo è quello di replicare gli errori che fa il sistema con cui sono stati costruiti i dati silver, che quindi è una stupidaggine a questo punto, o quello c'ha, o quel partecipante c'ha quel sistema, usa quello, e quindi farà andare benissimo, 100%, perché farà esattamente uguale, oppure non ha assolutamente senso. Quindi è importante che i dati dei test siano gold, non siano silver, non si può fare niente con i silver, no, non si impara niente dai silver, si impara come quanto male fa un certo sistema che è usato di riferimento. Secondo, i task devono essere completi, non puoi dire che faccio un event detection con 27.000 token quando il dependency parsing ce n'ha 300.000. Tra l'altro appunto non userei l'Evalita che è 150.000 quando adesso c'è la Italian Dependency Treebank che ce n'ha 300.000, che appunto dal punto di vista del parsing è quella che va usata, non quella che è più piccola alla metà, come è stato raccontato oggi. Questo chiaramente vuol dire che le annotazioni che erano state fatte su quell'altra forma vanno riviste e ritoccate, quindi c'è un altro sforzo in più e questo qui non andrebbe considerato. Ho finito. Quindi, secondo, l'ultima cosa, cosa vuol dire task? Sì, sulla FacTA, cosa vi dicevo? Sul FacTA forse lasciare. Allora, rimane il problema, diciamo, di... non so se deve preoccupare, insomma, della visibilità. Allora, se l'obiettivo è la visibilità, allora dobbiamo pensare a una cosa che sia molto visibile nei media. Allora, raccontavo ieri un'idea così buffa, bizzarra, se volete, che avrebbe un enorme successo con i media, cioè quella di fare un sistema che crea il giornale di domani. Cioè, come si fa? Si prendono le notizie degli ultimi giorni e si genera la pagina del giornale di domani. E la valutazione è semplicemente fatta prendendo la pagina, facendo leggere a degli utenti, dei lettori, i quali dicono se quella pagina è credibile o no. Gente che ovviamente non ha visto le notizie del giorno e che valuta il giornale se è credibile o no. Siccome c'è una tantissima ripetizione sulle notizie, questo è un task che funzionerebbe benissimo, perché tanto le notizie sono quasi sempre da un giorno all'altro, non cambiano molto. E quindi però avrebbe un enorme effetto sui giornalisti stessi, perché a questo punto si vedrebbero il loro mestiere, diciamo, in dubbio. E quindi questo potrebbe essere, se vogliamo appunto una visibilità, diciamo, chiaramente non è un task scientifico come gli altri, però se vogliamo metterci qualcosa a fianco, diciamo, di quelli che sono i task, diciamo, di più tecnici, qualcosa che sia che colpisca l'immaginativo dei media, potremmo pensare a cose di questo genere.
Ok, allora scusatemi, purtroppo diciamo, i tempi sono talmente stretti che non c'è speranza di dare spazio ad un piccolo dibattito nel pubblico. Quello che mi sento di dire agli organizzatori, no, non lo so, il mio clockman mi ha detto taglia, se voi parlate con il clockman, perché io non... Allora, se mi date 10 minuti vorrei fare un altro giro diciamo, almeno ai panelist e a raccogliere un paio di domande. L'unico invito che faccio è che credo che Like debba fare un forum o una pagina Facebook, qualcosa in cui questa discussione possa essere proseguita nei prossimi giorni, fondamentalmente. Una sola premessa rapidissima è che gli organizzatori di questo panel e della sessione precedente hanno lavorato e che hanno raccolto il materiale, eccetera, eccetera, hanno invitato le aziende a parlare a questo tavolo e non trovo inappropriato una presentazione di 40 secondi di chi sono, perché non li conoscevamo, quindi per il resto non sono d'accordo con te su questo, mi dispiace. Allora, ci sono domande dal pubblico? Prima di chiedere raccogliamo un breve giro di domande e poi facciamo una rapida risposta dei tre panelist. Domande sintetiche.
Va bene, velocissimo. Prima cosa, anch'io penso che insomma va benissimo che Maria l'abbiamo invitata a questo panel, quindi che si presenti. Va bene, è giusto anche per noi sapere chi è, cosa fa. L'altra, poi complessivamente, insomma, un aspetto che secondo me dobbiamo tenere in conto organizzando Evalita è il rapporto costi-benefici. Cioè costa tanto, diciamo, organizzare i task e qualche volta poi abbiamo detto c'è solo un partecipante, non siamo riusciti ad avere abbastanza benefici rispetto al lavoro, all'investimento che è stato fatto. Da questo punto di vista, diciamo, se è possibile, diciamo, per esempio, usare crowdsourcing per i task, almeno il mio punto di vista è che l'associazione, diciamo, c'è, se ha le possibilità economiche per farlo, sono, diciamo, tutto sommato fondi che sono ben spesi, quindi l'associazione potrebbe aprire, diciamo, un account su Crowdflower, per esempio, e dire questo è a disposizione degli organizzatori dei task di Evalita 2016.
Beh, non dimenticate anche che AISV è co-organizzatore, quindi può contribuire pure lui. Quindi
modalità di questo tipo le possiamo discutere, però penso che siano tutto sommato ragionevoli.
No, io più che una domanda avevo 2 o 3 considerazioni rapide, nel senso che l'anno scorso in chiusura di Evalita avevamo fatto un panel che avevamo chiamato Poster Bianco, perché era molto tardi, in cui avevamo fatto una serie di considerazioni che riguardavano il futuro di Evalita. Mi fa molto piacere che appunto, riguardando i vecchi lucidi che avevamo preparato per l'occasione, che molti dei punti, diciamo, che erano emersi nella discussione che avevamo avuto anche estensiva con McDonald's stanno riemergendo in questo panel, in questa discussione. Ce ne sono 2 o 3 che non sono emersi e quindi mi farebbe piacere, diciamo, porre la vostra attenzione. Nel senso, nella discussione che abbiamo avuto, appunto, c'era il discorso, la valutazione secondo noi doveva risultare dalla combinazione di criteri diversi, perché in tutte le valite in qualche modo il focus era sulla efficacia del sistema, sulla performance e anche in quel caso magari uno poteva cominciare, come nelle valite anche scorse avevamo tentato di fare, di cominciare a introdurre delle misure che fossero più orientate all'applicazione. E quindi appunto, diciamo, sicuramente questa è una valutazione, come diceva, fondamentale, però diciamo, noi nella discussione lì, e appunto mi interesserebbe sapere che ne pensate, diciamo, avevamo posto altri elementi di valutazione che potevano essere interessanti. Uno, l'usabilità del sistema all'interno di applicazioni, quindi appunto, diciamo, anche processing speed o i requisiti di memoria possono sicuramente, diciamo, entrare in ballo. Un altro aspetto che mi sembra interessante, che poteva essere, era il rendere, in linea con quello che diceva Malvina, i risultati raggiunti replicabili e verificabili, perché effettivamente questo è un modo, in qualche modo, anche per continuare a costruire una comunità e rendere più visibile l'iniziativa. E sempre tra le open issues che noi mettevamo in evidenza era il fatto che la valutazione potesse anche considerare l'originalità e l'innovatività delle soluzioni proposte, non soltanto gli scores, perché per esempio nel caso di Parsing l'anno scorso, cioè più o meno tutte le soluzioni erano soluzioni, diciamo, esistenti che erano combinazioni di parser, quindi sostanzialmente studiare un modo anche di promuovere, di incoraggiare i partecipanti a proporre nuove soluzioni rispetto al riusare quelle precedenti.
Un ultimo commento, ce ne sono molti, ci sono molti ultimi commenti, quindi cerchiamo. Allora c'era Paola, c'è Giovanni Semeraro, c'è Viviana.
Posso fare un commento brevissimo? C'è questo problema dell'originalità, ma secondo me è in intrinseco contrasto col concetto di shared task. Cioè è così, cioè la shared task per natura è una gara che tu vuoi vincere. È come dire agli studenti: venite a fare l'esame ma non preparatevi nel modo migliore per avere il voto più alto. Cioè, secondo me è impossibile, lo sappiamo che la shared task, soprattutto se è una ripetizione degli anni precedenti, la cosa migliore è combinare gli anni precedenti e hai il sistema migliore. E allora dobbiamo fare delle valutazioni diverse, non la shared task.
Allora, Viviana e Giovanni, poi chiudiamo e diamo un rapido giro di risposta ai panelist e poi Viviana e Giovanni. Viviana...
Una cosa velocissima solo sulla proposta di organizzare delle sorte di track, di task. Questo a me piace molto e va anche nella direzione di quello che diceva Beppe, cioè nel senso, per esempio, la track di sentiment, secondo me, assolutamente deve riproporre il task esattamente come l'anno scorso, nella stessa forma e non più complicato. Dopodiché si possono avere, soprattutto se si riesce ad annotare gli stessi dati con altre annotazioni, delle declinazioni magari più complicate del task in cui si cimenteranno quelli che in questo momento si possono cimentare. Anche a Semevali in qualche modo fanno così, cioè il task di sentiment semplice e poi ci sono le articolazioni che man mano vanno verso l'aspect based o verso l'entity linking o quello che si vuole. E per il parsing potrebbe essere lo stesso, chiaramente deve esistere sempre il task di parsing, dopodiché ci può essere anche il task innovativo che magari poi verrà deserto, chi lo sa, o magari chissà, e secondo me l'idea di avere delle track può andare in questa direzione, di mantenere comunque l'idea dello shared task anche come momento di confronto della comunità sui task di base per vedere se si cresce, e però magari dare spazio anche a qualche idea di merging di task o di innovazione, che poi alcune delle cose che sono state proposte sono in linea con quelli che sono i task di Senegal, almeno sul sentiment, quindi non è che siano proprio cose che non si sono mai viste. Per questo.
Corri.
Una considerazione e una proposta alle aziende. Esiste da un po' di tempo, è stato un caso di successo in ambito recommender system, il cosiddetto Netflix Prize, vale a dire un'azienda aveva un interesse specifico nel migliorare il proprio sistema di recommendation, cinemaffi, e ha deciso di devolvere una certa quantità di denaro, $1 milione, a quel gruppo di ricerca, a quell'algoritmo che avesse migliorato il 10% i risultati. Allora io penso che, di qui l'invito, questa è la considerazione, è finita qui. L'invito alle aziende sarebbe questo: loro hanno i dati, ovviamente decidono quale porzione di dati mettere a disposizione e sfidano noi, che siamo gruppi di ricerca, a migliorare di un certo X% la qualità degli algoritmi che loro già utilizzano. Tutto qui.
Ottimo.
Io potrei anche proporlo a qualche azienda in futuro e secondo me accetterebbe.
C'è l'ultima domanda di Alessandro e poi do la parola ai panelist e chiudiamo, altrimenti Fabio mi ammazza.
Brevissimo, riprendendo anche la questione del... Allora, prima di tutto una considerazione, giusto aumentare la tipologia dei task, troppi task fancy secondo me non sono il modo per migliorare la cosa, l'iniziativa. Bisognerebbe anche porre una grande attenzione per, come dire, migliorare i task esistenti, quindi ad esempio variare le tipologie di dati su cui si lavora e così via. E da questo altro punto di vista, siccome credo che uno dei valori aggiunti delle campagne di valutazione sia anche la creazione dei dati, e da questo punto di vista, visto che viene chiamato in causa anche uno sforzo dell'associazione, secondo me diventa strategico magari non aumentare in maniera estensiva, come dire, le tipologie di dati che vogliamo creare, soprattutto quando poi magari i dati da creare sono difficili, hanno un basso, diciamo, una bassa reliability e così via, ma magari spendere tempo, cioè magari, per dire un esempio molto concreto, mi piacerebbe magari avere più dati sintattici annotati, magari su tipi di testo che non abbiamo, su tipi di costruzioni che sappiamo essere critiche, piuttosto che avere yet another semantic level, molto bello, ve lo dice uno che appunto ci lavora sulla semantica, però poi alla fine è un altro pezzettino di dati che abbiamo a disposizione, e poi magari per migliorare i nostri parser, di quel 5% che dicevano anche Google, no? Che poi è il 5% critico, non ci abbiamo i dati, tutto qua.
Ok, allora adesso sempre per motivi di cavalleria le risposte facciamo al contrario, da destra verso sinistra, così l'effetto memoria breve termine lascio a Maria come ultime parole ascoltate.
No, niente, io dico semplicemente ottima idea quella di Semeraro, mi associo completamente.
No. Allora, un'altra cosa che si può fare in realtà per coinvolgere le aziende è magari pensare degli stage che sono presso un'azienda, che sono mirati specificamente alla partecipazione ad un task, e secondo me anche questo potrebbe essere interessante, cioè tu mandi lo studente a fare esattamente il task. E poi, no, vabbè, l'altra cosa che volevo dire rispetto agli score, che è vero, e questo riporta poi alla questione aziende che non si vogliono esporre nel caso poi ci sia un risultato non particolarmente positivo, però l'idea di E non risolve probabilmente la questione aziende, però rispetto all'innovazione, se tu consenti comunque la sottomissione di multiple runs, puoi comunque avere lo stesso, lo score più alto con un sistema che non fa niente di innovativo, hai cambiato un parametro, hai scoperto che è fantastico, però puoi anche sperimentare con delle cose alternative e mandare run ulteriori. Tra l'altro se ne parlava anche ieri con Nicole, Pierpaolo e Valerio, dicendo che nel report del sistema sottomesso si dovrebbe chiedere che ci sia una sezione bene ampia in cui si specifica che cosa si è innovato rispetto, cioè proprio per forza spiegare qual è l'innovazione, qual è la differenza rispetto ai sistemi dell'anno precedente, anche se costruisce su quello. Però secondo me le multiple runs sono già una possibilità di dire, vabbè, io mando il mio sistema migliore, però intanto provo anche a fare queste altre cose e le posso mandare lo stesso. Sì, sì, anche...
Maria.
Sì, innanzitutto proprio non volevo veramente fare autopromozione, quindi mi spiace moltissimo che sia stata presa in questo modo, perché proprio non, quindi mi scuso se è stata presa in questo senso, non volevo proprio farlo. Sono assolutamente d'accordo sul fatto che le misurazioni siano indispensabili, l'ho detto, le usiamo continuamente e è inevitabile farlo, quindi anche su questo sono assolutamente d'accordo senza aggiungere altro. Se c'è un'intenzione a mantenere Evalita con un taglio strettamente accademico, non è che le aziende stanno premendo per entrare e Evalita deve difendersi dall'attacco dell'approccio commerciale delle aziende, cioè mi sembra che sia, io sono stata invitata qui, non ho chiesto io di venire, nel senso io e insomma le aziende, mi sembra che sia un problema che si sta ponendo Evalita, che quindi siccome la collaborazione tra aziende e università è sicuramente proficua ed è sicuramente un aspetto da incentivare, credo, nel nostro paese, perché poi finisce che ci prendiamo i ricercatori all'estero e anche che magari se no si rischia di fare la ricerca sganciati dal sapere cosa serve nel mondo invece dell'industria, che è solo uno degli sbocchi naturalmente, non è di certo che l'università si debba adeguare o il mondo della ricerca debba andare a indirizzarsi a seconda dei bisogni delle aziende, del commercio, del privato, assolutamente no, però può essere certamente una collaborazione interessante. Noi siamo disponibilissimi e non cito le altre cose che abbiamo fatto in questo senso per non rischiare di fare autopromozione, però ecco, da parte nostra c'è certo una disponibilità a trovare questa sinergia e degli spunti di collaborazione. Dopodiché, se invece Evalita sceglie di mantenere un taglio accademico e non ha voglia di porsi il problema di come aprirsi a altri tipi di esigenze, va benissimo, perché non c'è nessun obbligo, insomma, che questa campagna diventi qualcosa che non sente di voler essere, ecco, naturalmente.
Va bene, vi ringrazio.
Un aggettivo non mi è piaciuto.
Scusate,
accademico sembra detto con un'accezione negativa. Io ho detto scientifico. Il nostro è un compito scientifico, non è accademico. Facciamo delle cose che hanno rilevanza industriale, tant'è vero che abbiamo qui una persona che ce ne ha parlato, ma scientifico, l'approccio è scientifico a problemi che possono essere di rilevanza generale, compresi non accademico.
Ok, grazie a tutti per il contributo nel panel. Allora, adesso si pranza, però alle 14:10 riprendiamo con il panel delle industrie. Vi prego tutti di rientrare per le 14:10. Grazie.